Hopefully my audio's okay. The audio gauge looks a little different today, and I haven't had time to sit down and really figure out my audio again. I messed with the compressor a little bit. It might be too aggressive, it might not be smooth enough, it might sound like somebody's flipping the volume up and down. Because, I mean, that's essentially what's going on, but it's automatic. Oh no! My other copy is running. I didn't think it was. No, it's not. Yeah, suspend and continue. Yeah, it's not running on the other computer. It must not have phoned home its closure. Ooh, this is gonna use up a couple cycles that my computer's using otherwise to run itself. Wait, why didn't that show up? Are we bench pressing today? Should be. Why is Social Stream not picking up on? Did I pop out the chat? I thought I did. Where's that window? Yeah, there it is. Oh, we got to open up YouTube. That should be running. Did it open on the wrong account? No, it opened on the right one. Weird. I don't know. The Twitch chat not showing up. That one showed up. The toilet one. Pop out chat. I'm going to sneeze. Hold on. Oh my God. We'd be bellying up to the bench is what we'd be doing. Really? I have to completely log in with... Which account is this on? On the correct one, I think. Yeah, this one's... What the fuck? Why isn't that one showing up on the... Oh, did this open? No, this is all on the same thing. Why isn't it speaking to each other? What is going on with my stream setup today? Hold on, I'll get chat up on screen momentarily. I just need to figure this out. Yeah, I'm gonna go ahead and not log into Twitch, which is what it's telling me to do. Refresh this one. Ah, I guess my credentials expired or something. Huh. I'm gonna use all kinds of technology to get back onto my account here. There's this thing, and it says one. Got a code. Okay, now I'm logged in here. Now I can go and open up. I'm going to open up these again. I'm going to close all the web pages that I got open, except for YouTube. YouTube stays up, the YouTube chat. I'm going to close this Twitch chat, and then I'm going to hit the web pages button over here on my setup dialogues, and that'll open all these things again. And now, if I pop this out, this should likely work on that. All right, this is just what I got to do in order to make my chats work. So I have a universal Twitch and YouTube. And now we can open up Streamlabs and authenticate that with Twitch. It gets me in there. This one I already have open. I'll open it again. Although the Social Stream Blade is not... Seems not to be updating properly, although it should probably work now. Let's try it again. Okay, that's showing up. All right, now that works. I think everything works now. It's Twitch logged me off because my credentials have expired. You only allowed for like a month at a time. I gotta move the fan. I'm starting to sweat. How's everybody doing? Hedonica, Herr Bothan. Many Bothans died to get this information. Okay, yeah, we got to do some little checkups on what the circuit we built is, because we know the circuit that we built works. So we've got to check up on that, make sure that my schematic is properly representing that circuit, and then what do we do? And then we need to start putting down power traces, because it's about time. I did everything but power. I figured the best way to do a circuit board is you know, you do the breadboard circuit and you build the thing, right? And you build it and you get it working 100%. Then if you have any special parts that you're using only in the PCB, you want to adapt those to the breadboard, get that working, answer those questions. Okay, it works with the weird hardware that I want. From there, you go to design the PCB and you put your entire schematic down onto a sheet of paper with respect to what the hardware you're going to use is. So every part you put down in CAD has a physical representation of what it actually is. You get that schematic down in CAD as your master working document of exactly what's on that PCB, and then you go to the two-dimensional design with all of your components, and you try to group everything by functionality so that the air wires are clean. You're not putting down any traces yet. One of the most important parts from there is putting all of your components into the physical board. So you do all the physical board parameters. What are the exterior things that are going to be interacting with your board? What screws need to go down? What kind of clearances need to happen on certain areas? From there, you bring in your groups of components and you can start wiring them up. Now, depending on the hardware, there might be a lot of jiggling, a lot of sort of wedging to do in there. Like, oh, this resistor won't go there, it'll go here, blah, 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 blah. This mixer project was a poster child for that sort of thing because we just simply couldn't even fit the chips in certain places. So I had to stagger the actual connectivity of the board. So what happens is it goes from stage to stage to stage to stage, but it's actually stage to stage, skip, back, stage, stage. It's so annoying. I don't think this is actually DJ Everyday. I think it went to like individual music, didn't it? Let's just double check here. Where is my music coming from? Question number 2. Question number 2. There we go. It's coming from over here. This is not, this is district. Oh, but it's everyday at district. I guess I'll allow it. It might be a little like dark. I want the music to be a little happier. But yeah, so then once you get all that traced out, you then do power. Because power can wiggle around. It can go to a bunch of different locations to get to where it needs to go. And then from there, finally, you do board markings, stuff that the user needs to know, labels, and sign off, put a date on it. Then you can send it off to production to get a test board. So that is the way to prototype something nowadays. As your average suburbanite maker who knows a little bit more about circuits than I don't know, who knows about circuits. You basically go directly to the PCB. Now you can physically build the circuit with like a through hole or like a wire wrap or solder down trace kind of thing, you know, a perforated prototyping board, and build the circuit, but that is no longer a required step. It's no longer a required step. You do that and you can have your weird solder connections and your wires all over the place, your little bird's nest. That could run your whole project in ad infinitum. But $5 a circuit board. You can just skip that step and just go directly from the solderless breadboard to your PCB, and that's what we're doing in this project. There are parts falling off of my breadboard here. All right, so this thing's started up. Let's get our project open. Probably need to archive a couple of these because these are just files from external. We just brought these in as like the files that were on the internet, so that I could actually know a lot of these are front panels that I made only. That one's not, but I can maybe make a new and an old folder, and then the old one can get archived at some point. We can open up the whole project. If I open up the schematic or the whatever, it'll open up the whole project anyway. How's my phone doing? We're doing okay. I had a turkey sandwich. Oh, turkey sandwich, perfectly healthy. That's a nice lean meat. Yeah, except it was on a pretzel bun. Pretzels have a lot of carbohydrate. Pretzels and bagels are dense. They are dense. They have a lot of carbohydrates in them. I don't know why everybody needs to have a special bun on everything. Everything's got to be brioche sweet on a special super spectacular bun. It's a simple sandwich. Just needs to have something soft, maybe multi-wheat. That's all I need. But apparently everybody's got to have some crazy thing. So yeah, so that was the only good supermarket sandwich that was available. And it was on a pretzel bun. And oh boy, there's a lot of carbs in pretzel bun. And then also the Red Bull that I drank a couple sips of, it said 0 on it. You know, like Coke Zero that has 0 calories? This said 0 on it. And apparently, according to fucking Red Bull, 0 means 0 added sugar. It already had 40 carbohydrates in the drink. So I had to stop drinking it and put it aside. This is going to be a Red Bull day. I was going to be buzzing around on here on camera. Actually, no, Red Bull doesn't do anything to me. But I would have been at least a little bit more awake than I am right now. So we're back to water and seltzer as our drink, which I guess is good for me. Okay, so here's the question correctly going into the right pluses and minuses, and is the ground correct? I think I was careful to do that back when I put this together, but that was like 5 weeks ago. I lost a significant amount of work on this project because of the grid. The grid and my own mistakes pertaining to the grid. Certain areas that have to be kept out of and certain spacings that were English. You can see here that this trace is not on the grid. And I regrid this thing into an inch grid, or sorry, millimeter grid. I'm using 0.1 and 0.01 as my grids, which makes for some trouble around these English space, the 1.27 millimeter spaced parts. Like for instance, this ain't happening. I can get 3 traces through here. It just takes a little bit of wiggling, but yeah. And then on the keyboard project, that's on an inch grid. So I know that my parallel lines are not as small. They're not as compact as they could be. I guess it's good that I keep them a little bit more separate because maybe there would be a little bit of crosstalk, possibly from all those parallel runs. But at the same time, I probably could have designed that board a lot better. But I'm not going back on it. I'm going to get that one made and we'll figure out what all of the issues are with it and maybe get another one printed in the future. But I'm still not, the temptation to go purely to the RP2040 exists. I have a bunch of these Pico Pis that need a job. So I think that's going to be a good application of them, is just putting them on the keyboard and then get that closed up and not think about it again for a couple of years when after I make a CNC machine, I get some burl wood and make myself a cover for that snaps open with magnets. But that's not yet. That's not for some time. Oh, everybody's gone. Everybody's busy this month. I guess that the new work year hits pretty hard. It's nice to have dreams. They're like fucking balls and chains that I have to drag around with me. Getting a consistent look out of this circuit board has also been kind of difficult. I guess most of this stuff I'm doing just for appearances, just to make it look neat and tidy and to make sure that some ground planes can actually get in there. But the problem is a lot of spaces I've had to do some very distinct retooling in order to get all these traces to get through to the right part. I have about 2-4, like I can get 8 traces through the spacing in these pins. I really hope that these pins fit in these holes. I'm gonna have a conniption fit if they don't, because these are huge round holes and I definitely need that extra little space that the slots offer. Don't forget this keep out. This is an important one on the top layer. Man, Everyday really chooses songs that have these slow, almost methodical builds in them. I love it. It gets very layered. Look at all this crap. And there's this little area all the way up here where I need to route a couple things still and sort of optimize these. I need to swap around what the components do. There's 3 op-amp circuits up here with their components. I need to have them logically exit over here and somehow make all of these connections. So I have one more of these to make through this area. This is blocking a lot of stuff. I don't know, I can't really do much about that. You know, if I flip these two, then this has a long path there and it blocks more. That's what it is. I mean, making a circuit board is all just this big sort of rearranging game, trying to keep everything as flat as possible. What's the actual reason for ground planes? Assuming that's the filled area I see on PCBs. Yeah, ground planes are filled areas, and sometimes you make those like power signals. Usually you make it a ground. What they do is they essentially are wrapping your circuit in foil. They keep things quieter by putting things in like a can. If you've got 4-layer PCBs, it is very prudent to have ground planes sandwiching your high-speed signals and stuff like that, because it isolates it and makes it a cleaner signal. In the grand scheme of things, the ground is taking all of your current back to your power source, and so giving it a nice wide berth is always nice. And then in addition to all of that, it also can be a primary conductor of static electricity. The static electricity is very harmful to complicated digital circuitry. And if you get a static shock, basically it's going to disperse evenly on your whole circuit board. You want to have a lot of that even amount of dispersal go through your ground plane. You want that to be your least resistance path, because it will take every path, but it will take the least resistance path the most. So yeah, and that's essentially it. Carry current, carry static electricity, clean up signals. Those are the primary purposes of your ground planes. But we're not super high-speed signaling. We're analog circuitry, and we're not all that sensitive analog circuitry. We're just doing audio. This is a big choke point right here, though, because I've got all of these signals coming in. These long traces are coming into this area, and I've only got the space between these two to route them up to the top. It's only 4 signals at this point. All the other ones have been bled out. They're gone. But these 4 signals, I need to get up through this area. So I'm dropping 2 of them down so that they can go over to here, I guess. Actually, we don't need these. And then 2 of them, well, 2 of them need to drop down, and then 2 of them need to just go over to that area. This is an unfortunate one that I can't get around. I could try to squish this down a little bit more, but I mean, this definitely has space to go downwards. But I don't think it'll accommodate an entire capacitor. Plus, I got tons of room up here. Everything is like free and clear up top. A lot of little considerations and decisions like that sort of revolve around circuit board design. And a lot of it is just get into it, just do it. I don't know what the auto router would have done with our board. I don't think the auto router would have done a good job. It maybe could have gotten it. I haven't played with AutoCAD's auto router. We also have to look at this lamp. I have a makeup mirror in here. This makeup mirror, for some reason, isn't working, and my poor old mother does not want to stop using it. She wants the same makeup mirror to work again. Might be that there's LEDs inside. It might be that there's bulbs inside. But we should try to pull it apart. It's the second such makeup mirror that we've had to look at. This one goes directly to the wall, though. Switch seems a little crunchy, but should be okay. And then this is looking like we can take off the front cover. Let's do that real quick. Let's do that real quick while we're sitting around. My brother got me a screwdriver kit for the holiday. He got me this thing. X-Cool. I don't know about it though. It's an electric screwdriver. I only have one. I don't mind the DeWalt one, but that one's a little bit. Yeah, it's an integrated ring light. It's just like the other makeup mirror that we had in here a little while ago, but this one is older. And this one's attached to the wall. We need another screwdriver. I need a different screwdriver head on this. Get this thing over here. Oh God. There's a lot of stuff on the desk right now, so I don't have a lot of room to work. I've been figuring out how to get into these sun-off light bulbs. They're cheap. The only problem is, they're cheap, but they're glued together at the top. They're glued with Celastic, so you have to pop off the top plastic bulb. It should unscrew just by going like that and lifting off, but they sealed it up around here. The only way for me to get Tasmota onto this thing, other than going through some really weird steps with Linux and Wi-Fi, is to actually remove the electronics from them and then go directly into the ESP and reflash it. So I'm going to have to figure out how to do that soon. Now that we've taken apart that Bluetooth one, I have decent access to the rest of the... I know how to get decent access. So we're going to have to pull those apart at some point and flash them with Tasmota, in which case I can then get some kind of a KDE fit. KDE? Is that... That's not right. What am I saying? Whatever the API is for my file server, and then I can set them up as warning lights, smart status warning lights. Hacking light bulbs. Yeah, it turns out it's a lot harder than I thought it was. I thought I was able to do it over the air just simply, but there's a whole thing. You can get into it if it uses some kind of like a smart home thing, but these are not going to have old firmware on them because I just bought them. Come on. This thing isn't exactly falling in line to come apart. Jeez. You gotta take it off like a cookie tin. It's gotta all come off at the same time or else it binds. There we go. Ah, we're just a normal light bulb. Normal light bulb. $25 watt. Why didn't they do this instead of taking it off of the wall? This looks burnt. Let's check. Why would they do this instead of... Come on. What is her problem? Yeah, this might be 5 times the amount of work. Of course. How should I have known? All right, I don't think we're getting ohms across this thing. So yeah, we need a 25 watt, 120 volt type T bulb. The new ones that are designed just like this have LEDs in them, and you can't replace the LEDs, and so they burn out, and that's it. I don't know how many turns this thing has too. As long as it's not too many, it should be okay, unless they actually have some kind of a buckle in there. What are we releasing the magic smoke out of today? Well, it was a makeup mirror, but it turns out the magic smoke is just fine. And then I know what I need to do in order to get the LED light bulbs working again. The ones that I bought that are just LED light bulbs. But we're not working on them today. I might save that for a Friday, is Tasmotizing these bulbs, because we got to rip them open in order to get Tasmota on it. Otherwise, it's a very complicated procedure that relies on old firmware in the bulb. And since I just bought these, I don't think they're gonna have it in there. So what we'll have to do, probably tomorrow, we'll rip off the tops of these, pick out all the Celastic, and then get the PCB out. We got to pull the backing off without destroying it this time. And then bend the wires over, take the thing apart, and we can get to the pads that are on the ESP that's inside of it. Once the ESP is initially flashed, then they'll be Tasmota. I'll never have to open them up again. So I could either use pogo pins to do that. I wish I had a couple of those little arm things. You know, those, I used to have access to them, but the little poker majigs where you adjust it from the back with little screws and it just pops the pin down. Best I've got are some probe hangers, but I guess I could solder wires to it. That's probably the best way to go. You just solder 4 wires to it. It's an SDA, SCL, or whatever. It's some kind of a, I think it's the TXRX, so the serial thing. And then we flash it, we Tasmotize it, and then that's it. You just define it as the sawn-off RGB LED. Bob's your uncle. Put it all back together, and then I have a light bulb that I can control that doesn't phone home. I don't want my goddamn light bulbs need to speak to the factory, but they do, which is insidious. So people like us, we know how to kind of get our dirty, nubbly fingies into all of our electronics. We can get in there, we can reflash it. That's the beauty of Tasmota and those other things, the smart home kind of stuff, is that you can get in there, replace the firmware, you get the cheap hardware that they make cheap because they feel like, you know, oh, if we get your data, we'll sell your data, we can sell a product for a little less. So, but we get that deal without that transaction. We don't give them any data. Good stuff. You should stay with the makeup mirror. Keyboard, can you shove over a little bit more? Probably not. I'm running out of space. Ain't got space. We need to move the mirror somewhere else. That one's going to be a little while because it'll require the purchase of a light bulb. Can't believe they couldn't just take off the front cover and replace the goddamn light bulb from the start. The whole game was rigged. Oh, I need to get my microphone cable off of this. Let's go to the face cam. Oh God, this thing is a life of its own. All this nonsense that's off axis. Let's just put this right here. What is that? Some nasty shit dripped over there. Maybe I sneezed. Nasty. Nasty, nasty. How are we doing today? How are we doing? Currently, my glucose level is being completely ravaged by a pretzel bun and 2 sips of a regular Red Bull. Look at that. 7 units right there to try to tame this thing. Fucking hell. There was also another bolus on top of that, but it's like it didn't know how much it injected. So there was a miscommunication. So I've got more than 7 units active right now. What thing you got? I mean, it's the beginning of stream. It's allowed to be very distracting right now. Oh, okay. Hey, you do you. Whatever you want to do. So yeah, I guess we'll do sawn-off hacking tomorrow, and that'll get me... I would really like to get these things working as status lights. One of them will be maybe a stream status to tell me whether or not I'm broadcasting, so that I don't leave the room while broadcasting. One of them can go red, and then we can think about other signals for that one. And then, you know, maybe it can flash yellow or something when I get a subscriber. And then the other one, I can do smart statuses for my server, and I can have it go as weak as it goes green, and if something happens, it'll go bright red. That'll be the idea for these. And maybe in the future I can roll a couple other alerts in there. But I mean, green and red are the most prominent alerts. They tell you, yeah, status good, status bad. And it's that simple. But I'm champing at the bit to work at this thing. Smart insulin pen. Okay. I mean, they put electronics in all kinds of stuff. Even my screwdriver has to be smart these days. Even my screwdriver has a mind of its own, phoning home at China. I'm already on an insulin pump, so I don't really need a smart pen. I guess it would be clever that it would do all, like your phone could do all the math for you based on your blood glucose level, and then you just hit yourself with the injection. I'm beyond manually injecting, although I still do it. I do it to conserve insulin. This thing my brother gave me for the holidays, it's okay. Oh, if you double tap, it sticks. I didn't know that. It's got a light. I don't know. The DeWalt one is much larger. I think it's better for screwing tasks. I don't know if I'm ever going to bring myself around to using an electronic screwdriver. Yeah, you know, hey, I hope it helps somebody manage their diabetes, because I know of people that are on insulin pens, even type 1 diabetics that have just remained on insulin pens, because you find something that works for you, you just use it. And so maybe a smart insulin pen will help somebody out. I don't know. But I don't know, if you're to the point where a smart insulin pen is going to help you out, you might want to look at just a pump. I can move this over to the side, but I don't really need to. I got a lot of stuff to think about with this. This is more DJ Everyday. This is a Burning Man set from 2019. I went to Burning Man in 2011. My diabetes management... Whoa, why is this thing so tight? My diabetes management was much different back then when I went to Burning Man. I was on an early version of the Dexcom, and I had a Tandem, or was that before the Tandem? I think I had my normal insulin pump, the 512 or whatever, the Medtronic, which nowadays, the older Medtronic pumps, the ones that had a feature where you could wirelessly bolus and basal, you can get a little device that you put in your pocket, and it'll attach, it'll manage both pump and Dexcom in the way that I do. It's just an alternative way to do what I do. CES, I saw a brand called Vivi showcasing a pen called this CapSmart. CapSmart, what does it do? My boss at one of the government jobs that I had, my boss had this pen that he would write on a special notebook with. I think it was special notebook paper that had like this bedazzle kind of like dot structure to it. The thing about the pen was it was huge and unwieldy, but it had a little camera in the tip, and he was able to write stuff, and it would keep his notes digitally. So he was able to organize his notes really well digitally using a smart pen. Oh, for diabetes and insulin pen. I see. Maybe is that what Lawn Dog's talking about? CapSmart? I don't see pen therapy. Insulin pens are weird. Insulin pens are weird to me. Insulin pens are easier to carry around in public if you're doing manually injected insulin. Like if you're cool managing your diabetes like that, it's fine. It's not how I do it. Insulin pens are these big plastic pens that have a syringe in the thing as like the tip, and it's basically something that goes around the bottle of insulin in order to turn it into a type of giant syringe. And so it's got like a little limiter that keeps you from injecting a lot of insulin. I would assume that a smart pen, you hit yourself with it and it injects a certain amount of insulin. Syringes and bottles do the same thing. And having an app on your phone that tells you how much to inject is, I feel like the effort to dial in the amount of insulin, get the pen ready, sterile tip on the needle, jab yourself with it, press the plunger, get the needle off of it, put it away. Same effort to get the pen, pull it out, tap the app a couple times, hit yourself with it, let it inject, sterilize, put the thing back, put it away. Same amount of effort. Only this time you have to involve your phone. Father uses a pump, not sure the brand. Yeah, all the pumps are pretty different from one another, but the end goal of the technology is that you have that injection, that site on your body where there's just insulin being pumped into constantly throughout the day, and then if you eat something, you tell the pump what you eat, and it will give you a little bit more insulin as a bolus. That's essentially what I've got going on, except I only have to pull out my phone because the pump can stay away. The phone is coordinating everything, and it's getting data from the Dexcom. That's sort of the new layer to all of this diabetes management thing, and where most of the cool innovation is that we've got all these devices are talking Bluetooth, and so we have a device that speaks Bluetooth and has a brain in it, and also can do outward communications, and so it can tie a lot of the different menial tasks of diabetes management into something that's automated. Now, the scary part is they're going to start saying AI. They're going to start using that word in order to get the investor buzz we can use smart AI to manage your diabetes. I will never trust an AI. I will trust an algorithm to manage my diabetes, not an AI. But what I have is working, and I'm going to continue to use what I have. There's a new version, version 3. Yeah, CES is a lot of hot air. There's a lot of hot air at CVS. CES. CVS is also a piece of shit company, but CES has a lot of smoke. Some guy on Reddit 10 years ago is going to manage your diabetes. Can't wait for AI toilet paper. The AI algorithm will tell me how to wipe. Please, I need this in my life. We've got the richest man in the world with a vendetta against possibly the dirtiest man in the world, the Asmongold Elon Musk's kerfuffle, where he's releasing DMs because he thought he didn't understand what editor means. Like, you have people edit your YouTube videos. It's not like a magazine editor, but he misunderstood and got rid of Asmongold's checkmark. Why is that guy famous? Both of them. Why are they both famous? There's so much just slop out there trying to get your precious attention span. Why don't you guys come in here, come onto my stream? I'm not trying to get your attention span. The only disinformation you're going to be served on this stream is because I'm dumb. It's because I'm dumb. That's just dumb. That's the only misinformation. It's misinformation through negligence. That's all you're going to get here. Nothing here will be determined by AI. I can give you that much. An AI aimed bidet. Sorry, bidet. Just a little. That's not even. I want to get this keyboard circuit ordered soon. And then the other thing is, on this board, I didn't consider the routing layer. For each one of these potentiometers, there needs to be a little cut of 0.5 millimeter into the side of the board. We haven't done that yet. For the prototype, I'm not going to do that. Once I get all these traces down, I think it'll be not easier, but it'll be just more possible. You know, that if I ignore this problem now, maybe it won't bite me in the ass. Here's an area that it will, though. That's going to be a difficult part right here and right here. We've got room over here, but over here I may have to do something crazy with RN2. And that may just be popping it back up right here and sneaking through here. Or I could go under there and pop up here and then just throw it into this bus. Oh God, there's just not room. There's just not space. It'll post it on social media. It'll let all your friends know. Hey, I cleaned my ass today. Praise me. And we still have to do power. Yeah, maybe we can make it wireless. Yes, this is part, and I've explained it 1,000 times, and I know you were there for that. I I designed this to fit in 2 HP. That's the entire 2 Euro rack slots. That's the whole thing behind this mixer board. It's supposed to fit within that small amount of area. And so that's what we've been working on all these weeks to do, is make this fit into 2 Euro rack. I can't believe 1 Euro rack is that narrow. It's 50 millimeter. Anyway, it's a 100 millimeter board. That's the size of two Euro rack spaces. Sub notifications are broken? What happened? There's a lot of stuff that's been messing up. Oh, NianoCat, 1 minute ago, subbed for 15 months. Hey. The last one was 5 days ago. Where did the sub notification go? There it is. I see it. I see it on this one. 16 months. Hey, thank you, NanoCat. I really appreciate you. It was AI. AI ate the notification. Yeah, of course. AI keeps messing with me. Get out of here, AI. AI pissed in my pants. What's up? Nothing's working. Oh, you were saying hi to. Sorry. I read and processed that before I should have. Okay, there's that notification. What windows don't I have open here? I think I'm good. I think I got everything I need. There's DJ every day. Twitch, we got this running. Where's my other window here? Oh, I don't have one. Okay, so the research window. Hopefully we don't need to open stuff up to take a look at data sheets. I just need to verify what's in here, that it's the exact same thing that's on the breadboard. Hey, nothing's working. How's it going? Hey, what's up, Baloo? How you doing? 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 It's a boy. Yeah, it has been a minute. We've been working on modular synthesizer stuff, and one thing leads to another, and then I end up doing a whole bout of PCB design work in order to, first of all, justify my free copy of AutoCAD, of Fusion 360, and maybe a couple other little accoutrements. It was that, or I convinced one of my neighbors to print out on letterhead, on university letterhead, that I'm in their CAD, or that I am the professor of a CAD modeling class or something, or that I'm in their CAD modeling class, and then I fake my way into a copy. But at that point, I had been contacted by the Fusion team about a creators program. So I can actually, and today's not going to count just because I have just a glut of streams where I can count them. But if I say it's hashtag an AutoCAD ad twice a month, if that, they will allow me to have this free copy of their software. So we're going to do that. We're going to do that going forward, because that happens anyway. It happens anyway. I'm always using this software. It's just because it's what I know. I like it. It's clean. It works really well for the things that I do with it. It is not Altium. It's not going to do Altium things, although it might be getting kind of close. But from a hobbyist standpoint, for the purposes of the things I do on stream, it seems like, I'm always doing this kind of stuff. So have you been good? I've been okay. The usual. I need to lose weight. every singular health problem that I have is related to losing weight. So I got to work on that one. Love AutoCAD. It's just what I know. I haven't used the free KI CAD or FreeCAD, all those programs. I haven't used them. And then the two programs that I did vaguely know how to use, which was Eagle and just basically Autodesk software, AutoCAD Inventor, they were rolled into one another as Fusion 360. So no, all I have to do is Autodesk add or AutoCAD add. I forget which one it is. I only need that hashtag. Free software is the best. Even when it kicks my butt and I hate it, I don't know. I'm in a position where I don't have to care. But I'm sure those programs are totally fine, and I would be using them if I weren't in this kind of situation. I do have to get this one ordered. It's only going to be $2, but it's got these cutouts in it that are going to be kind of important to hacking the keyboard. And then going forward, there may be enough pins on the RP2040 that I wouldn't need all this extra technology that's hanging down off of this board. I can make this whole board just fit like right here. But that's for future bother. It's rough. Oh, being addicted to eating is one thing you can't completely quit. I know. I am currently being absolutely destroyed by a pretzel bun turkey sandwich. I can't even have nice things. Although I'm not particularly fond of the pretzel bun. Not particularly fond. I probably would have rather just had it on some kind of a wheat bread. But it was a pretzel bun. It tasted like a pretzel. And it destroyed my glucose level. Absolute fucking destruction. Then the Red Bull that I got, that I was gonna have a Red Bull, and then I would feel awake during this stream. But I looked at the label. It said Red Bull Zero. So I'm thinking Coke Zero, right? 0 calories. It means 0 sugar. I took a sip of it, and I'm like, that's a little too smooth. And it turns out that it has 40 carbohydrates to the drink. So put the kibosh on that one. Yes, as explained, I ate a sandwich with a pretzel bun. Pretzel bun's very dense. Pretzels are dense. There's a lot of carbohydrate going on in it. So currently the pump is doing its best to bring that level back down. It'll be fine. What does that mean? I don't, huh? Yeah, it's a 0 product. They say 0 on it, but 0 is not a recognized, it is a colloquially recognized term, but it's not a recognized industry requirement that something that is a 0 product have 0 carbohydrates. I don't know if they said 0 sugar added, but it just said 0. But 0 can mean anything, right? Yeah, it has a lot of nothing in it. There's no gold in it. There's no lead in it. Look, it must be great to have wonderful control of diabetes, but if I eat something, my glucose level goes way up. That's just what it does. That's me. The pretzel bun was unfortunately a mistake, but I'm not gonna go buy a new sandwich. I could probably have cut it a little bit. Native American water, there's almost, yeah, actually it turns out a lot of soda products are bottled locally. They're not shipping Red Bull in from England. We don't get that English water in our Red Bulls. This thing is stinking up the whole shop. Oh, it doesn't say 0, it says winter edition. Oh, this must have been next to the zeros and I grabbed the wrong one. It was the light colored can to symbolize 0 carbs, but this thing is 40 in it. So that's on me. That's on me. I grabbed the wrong can. That's what it was. I just didn't realize it. This thing is stinking everything up. Stinky, stinky Red Bull. Yes, you want Austrian water. That's right. I remember there being a lot of scale in the English water. And when we went to England, we went to London and then Cambridge. And I remember the water, at least in London, had tons of scale on it. The teapot was just coated. It was nasty, nasty stuff. Why do you have all these questions? This is just... What is on the board in front of you? We talking this one? That's the mixer circuit. We've been working on that for a while. Yeah, so this is a 2 Euro rack panel mixer. Two not AU or 2 HP. I don't think that's the right designation. 2 Euro rack wide. Euro rack is 100 millimeters tall. That gets us to like, it's like 102 millimeters or something. So 100 by 50 rather, 100 by 50 millimeters. And we've got to fit an entire mixer on there. The mixer is specialty. It's basically 2 stereo channels that are individually adjustable into the mix, and then a singular stereo output that's adjustable with its own volume knob. So in order to do that, in order to do 4 individual channels, separated stereo pairs, I had to have a voltage controlled mixer, which is why we have one of these VCO chips. To have volume knob, we need another VCO chip. So I use the same thing twice. These things are big. They only fit in certain parts of the board. I only want one PCB on this project. And then on top of it, the inputs, the voltage inputs to those chips are not high Z. They act as a resistor. And so having 2 different control points from one knob means that I need another op amp in order to get enough voltage in there and in order to stabilize the voltage, because there's multiple things. So we needed a lot of op amps on this circuit. This mixer turned out to be way more complicated than I had any idea that it would be. Way more complicated than I had any idea it would be. And in order to build with smaller parts, the op amps that I was putting in are untested. I didn't know whether or not these op amps that I was buying would work properly within the mixer circuit. So I not only built the mixer circuit, I built the mixer circuit with the proper tiny little parts, and then I have a specialty headphone amplifier that I'm using for it too. So we built it all on the solderless breadboard. Unfortunately, the whole project has been a series of things where I was like, I don't think this is possible, but I'm going to try and I'm going to build it. And I build it and I go, oh no, it's possible. We're on to the next step. That's what it's been like. Are you hot wiring an RP2040 into an odd Chinese computer mechanical keyboard instead of a weird 8051 chip? Because that's what it looks like right behind that. Yes, that is exactly it. It's actually not a weird, it's a code 10 keyless. Ow, why do I put my hand on this? This thing hurts. This is a code 10 keyless keyboard. In order to design this PCB, I didn't want to be just coming out of the woodwork, because I haven't designed a PCB in like a couple months. And so I felt a little bit code 10 keyless cactus. Yeah, it really is. This thing is all through hole parts. It hurts. So I didn't want to be just starting off from scratch with this one, because there's a lot of weird requirements in getting the thing really narrow. On top of that, looking at JLC PCB's prices, it turns out these flexible PCBs are $2. They're really cheap now. They used to be mind-numbingly expensive, but now they're really cheap. So I figured if I wanted to do a takeover, I could use the pinout from this chip and have those soldered down with a flexi PCB, have everything else stand off on foam, and then build the whole keyboard takeover circuit on a PCB, and it'd be nice and clean. The previous version of this had the same layout, but it had the RP2040, the 3 chips here, and then wire wrap wires attaching everything. But it works. The keyboard works great, and relocating the brain of the keyboard to the upper part of the keyboard keeps it out of the way of any water that infiltrates the casing. Austrian water is even more scale, but it's tasty. Don't they just brew water with the brew? Don't they have like strict brewing standards there with the water quality? Yeah. So in terms of like diabetes. This is not terrible. This is just what happens. You eat something and your glucose level goes up. With the management that I have, the insulin is being given after the fact, after I eat something, which is totally normal. I can pre-bolus if I have that kind of forward thinking and planning, but it's difficult for me to do. When this insulin is injected, it's being injected in tiny little increments to mimic what an actual pancreas would do in a normal functioning glucose devouring human being. You don't have the ability to be half hour ahead, but your own supply of insulin is more effective than external. Even still, you eat something, it takes a little bit for that insulin to start having an effect. And although the information is not there on this one, I actually do have the information on the autopancreas system telling me that I have this boatload of insulin that's going to start taking effect in the next couple minutes. And so it'll start pushing it back down. That's just how it works. You know, I gave all the insulin over here, and now there's actually more insulin than this. It didn't record the previous bolus because it had some kind of a bolusing error. Everything is fine except for the fact that I ate a pretzel bun. I've got it out for pretzel buns. But the control system is that when you inject insulin, you're injecting it into an interstitial layer of tissue. You're not injecting it directly into the vein. It doesn't go directly into, it goes into basically muscle, not muscle fiber, but the interstitial stuff, the stuff that's under the surface of the skin. And what it does there is it sits and it eventually gets absorbed into the bloodstream, but it takes time. It takes, like, for the insulin that I'm using, it's a 15-minute peak. I can get insulins that are faster than that. They're not covered by my health service. So yeah, the stuff I use is insulin asphalt, which is the same as Humalog. It's insulin asphalt. Same as Humalog, only a little bit cheaper, so it's only $150,000 a bottle. But that means it's got a 15-minute, I mean, the chart is in here. It's in the system. Where is that? Rapid acting OREF. This is the curve of the insulin effect. So that's what it takes in order to get the insulin in your body. There are ones that have much, much more aggressive curves, but again, my health system doesn't cover them. That's probably the way that I would be getting my A1C down. One of my cubs has a pump that I have to check every hour when he's at camp. Man, diabetes in camp situations. I've been there. I was always on the weakest hikes because, you know, I have diabetes, and so I had to manage that among all the other stuff going on. It made roughing it out there a little bit harder. I had some growing to do before I really could enjoy that kind of stuff. But yeah, it's always funny. You're trying to rough it, but then you have all this technology that you have to maintain. You're like, well, it's not really camp. I'm just sort of staying somewhere else. Kind of sick to be able to see this information live, not a reference chart. That's for you, your body graph. Yeah, I mean, yeah, you could always pull open a book and look it up and take a look at the pamphlet of information that comes with the insulin. I have that programmed into a device that's acting live in order to make it determine what actions it should take in order to manage my diabetes for me. I have that all on my phone, and if I want to look at what's going on right now, I can look at what's going on right now. This, some of the uninitiated might not know, is my glucose level right now. That's it. That's where it is. It's going to stick there for a little while too, just because it's something to do with the liver and the stomach, I don't know, doing stuff with the food. It's going to stick like that for a little while, and then when my insulin pump has loaded almost all of its contents into my body, it'll finally start to go back down, probably by the end of stream, which, you know, we started about an hour ago. I think I was like somewhere around here. And it's doing its best. It's going to manage that. It's going to bring it back down. But the whole point of the system that I'm on, if I required less insulin in order to have things happen in my body, that would do a much better job managing my insulin. I wish I could get more concentrated insulin into the thing, because if I can lower resistances to insulin that I have, body weight being the big one, everything will react a little bit more spryly to the control that goes into there. And I could be like Cluck J, who's the person that turned me onto the system. He's a fellow Philadelphian that has type 1 diabetes, goes to the same endocrinologist as I do, has watched the stream. And for him, he'll go to Taco Bell and get a Baja Blast, which is just a sugary drink. It's just a sugary soda. There's no reason to be drinking all that sugar. Why would you do that? But he could just go and get it, drink it, not think about it. That's the big thing about this. This system is automated. I don't have to think about it. For me, because I use so much insulin, before a meal, I'll say, how much is this meal going to be? I'll punch the carbohydrates into the calculator on the pump system. It'll tell me the amount. And then I tell it, I've eaten this much. I have bolused this much. Don't inject. And so I'll match its numbers and manually inject. And that way the big boluses that I need for meals aren't the responsibility of the pump to manage in the background. It can do that. I don't let it because I want the pumps to last a little longer so that I can build up an extra supply. And I'm not always changing them out. So I want them to actually last the full 2 days. The thing is, like, if I eat a big meal, it's going to be like 22 units of insulin, and the thing holds 200 units. So I've used more than a tenth of my supply of insulin in one meal. I have a home nurse come in every morning to give me a painkiller needle. There was somebody who was watching my stream back in the day who had an insulin pump, but it was filled with pain medication. They were giving little tiny bits of pain meds through the insulin pump. Pretty crazy. Yeah, I guess I can simplify it a little bit more, but I mean, you could feasibly install like a management software like AAPS. I guess you might have to fake it working or something. I'm sure there's programs out there that do that calculation. You don't need an insulin pen for that. I mean, I personally do that calculation when back when I would manually manage my own diabetes. Oh, I got a lot of active insulin coming up. I better back off on this number a little bit. This thing, the AAPS system does that for me as well. Yeah, that's what I mean. You don't need the pen to do that. Yeah, a lot of it gets away from eventually, you do the mathematical calculation, but then you kind of learn what you do. You learn how you sort of respond to stuff and what works in what situation. It becomes a little bit more intuitive and harder to explain. You get away from the numbers. It's no longer a numbers game, and you go, I need to back off on the insulin just a little. That's, of course, where mistakes happen, but eventually you get like that. Yeah, that's one thing that I no longer have juvenile diabetes, although I did. One thing that probably could have alleviated some of my parents' concerns back in the day would be to have the website you go to that shows all of the management decisions of the equipment. Although I'm kind of glad that didn't exist, because that put me on my own much faster. I was managing my own diabetes fairly quickly into the game. Hell on earth for my parents to have a diabetic son, but it worked out eventually. Nowadays, you can do the sort of upload stuff and see what's going on with your kid. And then when I die, you guys can watch this thing and see if anything happens to my glucose levels. Like, oh, fascinating. Look, his glucose level's going down. But he's dead. Fascinating. Okay, all right, I'm gonna stretch. Move your legs. Yeah, would it be its spike? Well, even in massive organ failure, all of the body's systems would still be trying to work. All the autonomous stuff. I'll just have to die to find out. Depends on what I die of. If I die of cringe, you guys would probably see the glucose level go up. He's cringing so hard, it's secreting insulin. forcing his beta cells to actually be alpha cells. Unprecedented. Yeah, I really don't know what would happen. All kinds of weird juices squish out in your blood when you die. And every now and then, I swear my body makes insulin. Every now and then, my glucose control gets so good and stable that I swear it's my pancreas has come back from the dead for a little while. I'm sure some scientists have already studied it. I'm sure there have been plenty of opportunities for people to see that data. I've not been privy to any of it, and I don't feel like my morbid curiosity is not getting the best of me. The voices are not going to win today. Yeah, I had something like that happen at a festival, but I think it was mostly due to activity, and then I didn't catch the glucose level going down because I'd been in the pool. I'd literally been in the pool. And I was drinking, so my liver didn't kick in to save my ass. So the liver was like, "Oh shit, we're fucking getting poisoned. This guy's drinking battery acid again." And then glucose level dipped real hard, and I passed out in front of my tent after having gotten dressed. Luckily, I was finished getting dressed, but I hit the floor and had a weird waking dream. It was that sort of Field of Reeds kind of thing, and then there were the kinetic vehicles there with the torches going, and everything was misty. It was a cool dream, but then I woke up on the ground with somebody over me going, "Hey, we got the nurses over here. You gotta follow their advice." They weren't allowed to treat anybody medically, but the guys at the nurses' tent could suggest that it would be a good idea to do something. And so they said it would be a really good idea if you drank this Gatorade. And as blood sugar was coming back up, it was like a weird control system where I would try to hold my arm out in front of me, and my arm would overshoot and not quite hit the right location. And I was having the time of my life playing with that. I said, if I try to put my arm here, I overshoot a little bit. And they looked at me like, he's on drugs. What drugs is he on? And I'm like, I'm not on drugs. I'm not diabetes. I won't hypoglycemic. I'm just having a lot of fun with my body coming back up. It was really weird. It was really weird to have a delayed control of your own body. Eventually, everything was just like, bing, and you're back up. But that's glucose levels for you. When you go low, weird things happen. Your brain doesn't know that it's lacking fuel. You say weird stuff to people. They get very worried about you. That also sounds like a lot of drugs. Yeah, well, that is, yeah. Not the delay of control of body, from my understanding, but I haven't done a lot of weird drugs. I have not done a lot of weird drugs. I'm fairly vanilla. What's all this? One minute I was helping with a bandage around my dad's legs, part of medical care. And she asked me to sit down. She thought I wasn't exactly all the way there. My hands were working, wrapping his bandage. And a minute or two after that, I was out. Yeah, those are tough. Your body doesn't really know what's going on. Yeah, the thing is, like, that waking up experience, I don't think a lot of EMTs really know what that's like, is when you wake up from something like that and somebody's trying to shove something in your face, you're like, let me get my bearings. And so that's a lot of that refusal of care that they experience, where you try to care for a diabetic and they say, fuck off, because it's suddenly somebody's, and you're like, whoa. I just need to, like, figure out what's going on first. But in some cases, rather, there's not time for that. You need to down the sugar immediately. A good person. You are a very good person, and I thank you, because I've known people who have had to do that throughout my life. It's nice that you guys are around. You folks are around. All right, I'm gonna get started here. So, music goes away. Always so much talk about diabetes. I know Bucklington does not need my freaking plug. That guy has so many viewers. because he's a very funny guy and he does a great stream. But he's also a type 1 diabetic, and so Bucklington is somebody to check out if you want to get all of the Twitch diabetes streamers together for one last ride. No, whatever. I've been watching a little bit of Bucklington in the background while working on the circuit board, so I'm just thinking about it. Society of High Sciences, what's this? Well, sure as hell ain't science, that's for sure. We had a couple scientific questions during the pre-stream, like, what would my glucose level do after I die? Because this thing would certainly still be connected to me after I die. Ignore the giant glucose level. That's from a pretzel bun I really shouldn't have had. And then on second thought, I probably should have also given a lot of insulin at the beginning of that. That's going to stick around for a little while. My pump system is giving me little tiny bits of insulin as we go. I also had 2 big sips of a 40 carbohydrate Red Bull before realizing that I grabbed the wrong one. The one that I meant to grab said 0 on the front of it, but it was also light blue and the text was hard to see. And so I accidentally got a winter one, which has full carbs. So 2 things together and it's just bad glucose levels. That'll eventually get handled. If it doesn't, I'm going to get a little aggressive and you guys will see me inject insulin on stream. I'm going to give it another like half hour to start going down because it expected these glucose levels here to be going down a little bit more. I'm going to have to get aggressive with this and really just kind of destroy it now. Insulin resistance is part of my shtick. We a lot of diabetes talk and I can't get around it. And actually right now I am going to give myself... Lawn Dog, shut the fuck up. I don't remember assigning you as the little gremlin on my shoulder. Oh, be a good little boy. You should have done this thing in the past. Yeah, well, you know. Fuck. All right, we're giving a lot of insulin. I'm going to give like 18 units of insulin here because this is a 300s level that isn't responding. So the way to get rid of some of these things is to give little bits of insulin, and my pump's been doing that, but unfortunately it's not doing enough. So we're going to give it a little boost here. And that's done. The I forget who it was. One of these diabetes things did a study that injecting through cloth has just about the same rate of infection as injecting directly to skin. So not even an alcohol wipe. No, I don't have time for that shit. All right, so back to here. What we're building right now is we are working on a circuit. Yeah, I know. Look, I could just change the title and call this my hardcore diabetes stream, where I do nothing but talk about diabetes all day. That happened. We've just been talking about diabetes for a full hour. I need to start the actual stream. So, what I'm doing right now is I'm designing 2 circuits essentially for 2 separate things. One of them is a QMK diabetes starting soon. A QMK keyboard takeover. Yes, man, to talk not to talk too much about Buck, but the people in his stream make all of those dumb diabetes jokes. I don't know how I got around you guys not making them. Maybe just because I'm so much of an asshole when you do make the diabetes jokes, which is good because they can get kind of tiring. You guys have been good about that. I haven't gotten the same level of commentary. But anyway, I'm working on 2 separate circuits and I'm building them with Fusion 360. Fusion 360, program that I know. If you do 3D printing and makering stuff, which is what we do, make stuff, you will eventually find yourself needing to make brackets and solids and things that you're going to 3D print. And the Fusion sort of ecosystem, if you're on a Windows PC, is really nice. I mean, you can go from designing a circuit board to having an actual 3D representation of the board that you can then design solids around. And so that's what I've been doing with Fusion 360. Now, 2 projects going on right now, getting me back into designing a PCB. And the 2 projects are QMK keyboard takeover. So Code has a 10 keyless keyboard. And I love the one that I use normally. The one that I use normally died because I spilled shit on it. I spilled a diet drink on it, no sugar in it. It got into the CPU in some way, and it just blatantly died. No amount of alcohol and cleaning and careful swabbing could bring it back. It might be the crystal that died. It might be an individual component that died. You know what? I don't care. Quick Mechanical Keyboard exists. Now, there is a sect of QMK people that are actually working specifically on the code 10 keyless. Think about this code 10 keyless. Normally in a keyboard, you would have rows and columns, right? And you scan through the rows and the columns to figure out what keys are being pressed. 10 code, building the board, decided to split up the rows and columns so that your home row, where your hands are normally sitting, are scanned a little bit faster. They're scanned a little bit faster in the sort of grand scheme of things, which I don't really think is true, because if you're going row and column on everything, then you're scanning it just the same as everything else, but all the rows and the columns go into the main chip. So maybe it does scan, you know, only these little sections. I could probably reprogram QMK to do that if I hook it up to the RP2040, but at the time, we were just trying to put an RP2040 with QMK in instead of the dead chip. So the dead chip has all these pads on it that lead to all the rows and columns. So in order to have access to all of those pins, I used muxes. And the muxes were Maxim products that I bought in 2002, 2001. A long time ago, I bought a whole bunch of these things. This was supposed to build a bunch of analog brain scanning probes. That didn't happen. So all these parts in my parts bin. So it was an easy no-brainer just to put some Kapton tape on the corner there, put the Maxim chips down. Well, now I've gotten to the stage of the project where I actually want to make this thing more organized and less of a rat's nest of wires. And so I'm building a Flexi PCB, because they're $2, in order to get that done. Now this board is pretty much at the end stages of the design. I don't have really anything else to do with this. I put a logo on it. I didn't put a logo on it. I put a date. I put my name on it, all that stuff. That brings us to the other project, the one that I didn't want to be rusty when putting together in CAD. This would be a 2 Euro rack unit mixer. It is a mixer that can take in 2 stereo channels. So that's 4 independent channels that are leading into a mix where it then has a volume control and a headphone plug for headphones, so specifically a TRRS. If you plug in one channel, it'll broadcast that one channel to stereo. If you plug in both channels, those two are separate, but their volume is controllable as one thing. 2001, must have ordered them from the catalog, or did you use the World Wide Web? I put together a bill of materials, and the research thing that I was working for ordered them, and I don't know how. What was DigiKey's website like back then? Explain which components will heat up when broken. No. What do I look like? I'm one guy. I'm one guy that's sitting here in a shop. I'm not doing unit testing of as a one guy. I am not gonna like drop test or figure out what my circuit is gonna do at 30,000 feet. Like, we can't do that kind of stuff. We just put the circuit together, and if it works, it works, and we continue to use it that way. And then maybe somewhere there will be a problem where you go, huh? And that's it. That's all. You just go, huh? And you move on with your life. Because I'm not 60,000 people designing a product that everyone's going to see everyday use of. This is a mixer that maybe 8 people will buy if I sell it. Hell no. I'm not going to figure out what will happen to certain components if things die. Now, what we did do is we did do an assessment of heat on this thing. I got the thermal camera right here. So when I powered this thing up, we were able to see all of the different stuff heat up. And it turns out this headphone amplifier over here definitely needs a heat sink. So what I did is I soldered a pin to it. I just put I put a pin on it. Just put a pin on it. And that pin is enough to disperse the amount of heat that chip produces. It's also a mechanical nightmare, because if I push down on, I have beautiful nails today. If I push down on this thing too hard, it's gonna like rip the pads off of this chip. We don't want to mess with that. And then this thing got so hot that it was actually desoldering some of the connections to it. That's why we need this thing here in order to dissipate some of the heat. So in the actual circuit itself, I'm going to have a big ground plane underneath this thing, as much as I can afford. Unfortunately, though, due to the layout of the circuit, that's going to be kind of difficult to do. Okay, so we've gotten to the point where everything is laid out, right? and I've got all my components in place, and the only things I need to route remaining are these 4 air wires. Air wires are essentially these white wires. Oh wait, 1, 2, 3, 4, 5, 6. Yeah, I think it's 6. Okay, 6 wires need to go from the bottom of the potentiometer to the top. There are restrictions though, and it's in the stuff that I've already laid out. Red represents the top layer, blue represents the bottom layer. On the top layer of the board, I have all of my controls, so there's almost no room for any of the components to exist. We can barely kind of squeeze in a resistor here. That may or may not still get in the way. I'm gonna have to assess that. If it does really get in the way, I might have to push it inwards. I don't want these to be inwards because these might be parts that I have to adjust. I might have to remove them and put them back in. So there's a lot of considerations here. If you'll notice, the knobs have been turned around. I had to unroute. I got to the point where I was putting power lines into this thing, and I was working all the power lines around, and I said to myself, I says to myself, which direction of this thing, which one is volume up and which one's volume down? Because that's going to affect where I put my V minus resistor and my V plus resistor. A potentiometer, you think about it very carefully, a little bit more carefully than that. You think about it very carefully. What a potentiometer is doing is you take a resistor and you smash it with a hammer, you pound it flat. You have this flat resistor, right? You have a certain amount of resistance from point A to point B, the 2 terminals of the resistor. If you add another terminal to that resistor and it's got a wiper and it goes back and forth on that resistive material, you are essentially making what is called a voltage divider. If you put power on one side, ground on the other, you have a certain amount of current that's flowing through that resistor. If you tap it at a certain location, you have one resistor on one side and another resistor representing the rest of the resistor on the other side. That's a voltage divider. What that does is the closer you get to power, the higher the voltage. Closer you get to ground, the lower the voltage. So from 0 to whatever your voltage selection is, if you put like a 100K resistor in there, 100 kiloohms is going to resist a lot of the current flow into that thing. So you've got this low current voltage source that you can then read with something like an analog pin on your microcontroller, or you can throw it into an operational amplifier where it can be amplified or damplified or whatever the hell you want to do with it. That potentiometer can become an input. And so in order to not deal with, what the dipole there, what are you talking about? No, so in order to not deal with the physical parameters of the potentiometer, if you put an audio signal directly into a potentiometer, it's not an unheard of thing to do, right? You guys have grown up with volume knobs on your various, what do you kids have now? Portable record players, MP3 players. You know, back in my day, we had the super look ahead CD no skip for 60 seconds. So you could take your CD player and you go, and nothing would skip until it really would. And then all of those had these cheap ass little volume knobs that are just these sort of barely passable potentiometers. And so eventually you're turning the volume up and down, you start to hear scratching. And that's because that wiper that goes across the resistive material has scratched up that material and it gets scratchy. I don't want those scratches on my professional audio product. So what I'm doing is I'm using the potentiometer to go into an op amp, and then the op amp will then supply the voltages that it needs to. That also means that if we have something that requires more current, it'll maintain the voltage on that line. That way we can have multiple different control points from one singular knob. So I have 2 independent channels now and 1 knob that controls both of their volumes exactly the same. Pretty crazy stuff. But that just means more stuff on the board. So I have done the normal steps to build a PCB, which is to do the solderless prototyping, get the concept down, get an idea of what the circuit would be, lock in the design of the circuit, buy the actual components that you're going to use, put those components into the breadboard so that your circuit works and you've got a full test that might be a little janky around the corners, but generally the proof of concept is there. So once we have the proof of concept, we are now faced with the realities of a modern society. We live in a society. We live in a modern society where a production house has this massive piece of factory equipment where they put FR4 into one end and out the other comes printed circuit boards. All they have to do is a little bit of panelization and design. So what they do is they open up their service for people to pool in, and then they'll send their big piece of FR4 into one end of the thing. It gets routed, it gets the traces deposited, it gets all the vias electrically plated in there, it does the solder mask and the finishing work. All they have to do is plug chemicals into certain facets of this giant printing machine, and it will poop out our circuit board. So that means that our circuit boards cost a sum total of $5 for 5 boards. You end up paying more on shipping for these things. So what that means is, instead of what typically would follow the solderless breadboard, typically would follow the solderless breadboard with a perforated prototyping board. But nowadays, because of the advent of machines like that, we can jump directly into the next phase, which is your first printed PCB. So that's where we break out the CAD software and we transfer exactly what we put here into a schematic, and we choose components that are going to fit on the sized board we have. Once you get that schematic in, you jump over to the two-dimensional board and you put in all of the non-negotiable actual physical things, the locations of knobs, the locations of switches, the board mounting holes wherever they may be. The overall size of the board becomes more clear as you do that. All the factory workers doing all the stuff in between, I can tell you right now, there are none. There aren't. They put material into the machine and the machine just does it. You have to see these machines. It's just a giant, like, stainless steel coffin, and out the other end comes massive circuit boards that have all been printed. It's an incredible thing. But these board houses just have one of those and they maintain them. And so what you'll do is you'll send in your designs and they'll figure out how to put hundreds of designs onto one big panel, and then they just shove it into one end of the machine. And out poops the other end all these circuit boards that they can then divvy out and ship to you. So anywho, I mean, I'm sure there's more to it than that, but I am severely boiling it down. But for the large part, from what I've seen of those machines, that is all there is to it. It's crazy. So yeah, there's no need to use a perforated prototyping board. What you typically do at this stage was you would move this, because this isn't viable for anything. We can't really even use this as just a little mixer in the shop. It's, I don't have inputs, I don't have outputs, it's just, everything is a mess. What you would typically do is you would then transfer your circuit to a perforated prototyping board, which is just a standard grid of holes that are plated. Here's a piece of it right here. You would transfer it to something like this. I don't think I could get this circuit on something like this, but I could fit it into a slightly larger module so that we could do a little bit more testing with it. I don't need to do that now, though. It's $5 for 5 boards. The only thing is my time sink into pursuing what is an impossible project. So the impossibility of the mixer project put us in a position where I didn't know whether or not the components would actually fit on this thing. So I had to build up some 3D components and then populate them on our board and see if I could get all the right functionality out of it. These are non-negotiable I/O. I need to have 2 plugs for each right and left input, and then I need to have a knob for each of them. That already takes up a lot of our space, and then a headphone output with a volume knob. Fortunately, that fits. That's all that I can fit. We also learned that the voltage-controlled mixers would not fit. They would not fit anywhere but underneath one of the knobs. So 2 of these knobs, underneath 2 of them, is the only place that I can actually fit these SOICs. This chip is a little bit eclectic. It's hard. It does a very specific job that only audio people have needed it to do, and only synthesizer people have needed it to do it. And so it only comes in a through hole or surface mount part. It does not have a quad flat no lead. QFNs are great when you're in a space crisis, not a crisis in space. I mean, you don't have a lot of room. These QFNs are great because they are technically hand solderable. We'll use hot air to solder them, of course, so that way we get an interface with a heatsink pin on the bottom, but they are technically hand solderable. I could hand solder that chip, or I could get a cheap hot air station to do it as well. But they take up so much less space and I can fit so many more parts around them, as opposed to the SOIC. Now, I could go to smaller resistors. That would also be another strategy that I could do, but I have a moral obligation to use 0603 instead of 0402. 0402 is too small to put markings on, and I want to be able to see at a glance what some of the values of things are. Can you operate the knobs with the jacks plugged in? Yeah, that's the whole purpose of these little guys. There's in the modular synthesizer community, the people who are doing these really small things, which we are capable of doing. I'm doing it now. Doing these little tiny modules so that you can fit like a ton of stuff in your small area. Yeah, the jacks will get in the way, but you can kind of reach through them and get to that knob. You can just kind of barely get to it and kind of just barely. But okay, so we're trying to make a prototype, and all along, God, these little alerts really need to go away. All along the way, I've been saying, can we do this? Can we do this? Can we do this? And I tried to get all of these components onto what is 2 Eurorack spaces. I can't believe that Eurorack is even thinner than this, but the Donkey Kong connector has been, this is called a Donkey Kong connector. This has been the darling of the modular synthesizer world because it's a decently made plug that fits on these 2 HP boards, and you know, it gives you a decent interface. It's a cheap plug, but it does its job all right. There are knockoffs. You want to make sure that your connectors actually have this little shoulder here so that it doesn't extrude the threaded piece through the rest of your connector when you try to tighten it down. But anyway, we're using those, and then we're using alpha standard, like alpha potentiometers. There's a car going by right now that's making a lot of bass. It's like woo, woo. It's really weird. It's really weird. So yeah, those are the components, right? And it fits perfectly. Unfortunately, I keep saying unfortunately because I didn't want these answers to be yes, I can do this, Julian. The answers have been yes, I can barely do this all along. This thing has been an exercise in stretching out O'Bother's capabilities to the point where it's all woobly and thin. Yeah, can I fit 2 big tantalum capacitors on this thing? Kinda, yeah, I guess I can. These are gonna be like $4 capacitors. They're gonna be really expensive. I need diodes on this thing though. There's no way I can do this without diodes because it's too easy to plug this thing in wrong. One of the big advocacy things that I've been doing is that these modular synthesizer circuits, my buddies keep breaking them. They keep plugging them in wrong and putting power and ground in the wrong places, and that's very much going to be a thing that can happen here. I don't have room for a shrouded connector, so if I put 2 diodes on it, I can make sure that unless they'll be breaking their power supply if they plug it in like with a home row error. Because these 3 pins in the middle are ground. The bottom one is negative and the top one is positive. So I need to mark on the outside of the board. Last thing I'm going to do is mark with a big stripe down here and put a big S on it. I could have done a full bridge rectifier, and then it could have been, you can plug it in either way and it'll still work. But this is a 2-layer board, and actually part of the challenge is to keep it 2 layers. This is actually not the current, this is the current render has all the traces on it. I laid this whole thing out, and then I discovered that my spacing was weird because I never bothered to do a proper spacing like thing. So I actually, where did it go? Oh, okay, where is it? Somewhere around here, not in this folder, I guess. There is a sizing guide that I built. Huh, what happened to it? I wonder if it got lost. I have like an actual hole guide. This is the theoretical front panel, but oh yeah, no, that's a 1 Eurorack panel. This is how I do the sizing of these things. It's the panel size is 129 point something something something, but the width of the actual Eurorack is determined by how many units it is. So 2 by 508 times 1. And that comes out to 10.16 millimeter. So I could technically put that 1/6 millimeter into the final design. What I'm going to do is design it without little cuts for the potentiometers and see how that assembles. I might have to put the cuts in there. I might have to file them in or something. I'll put it without the cuts for now and see if that works. And that 0.16 might be the width of the metal. Which means that maybe I don't need to do cuts on the final thing. The cuts would also help me get them into the right position though, because the front panel will have specific cutouts. I don't know where that file went. It's in a weird directory now. I don't know where that ended up. I'll have to search for it. there's a file called Hole Guides somewhere. Maybe if I open up my other copy, it'll know where it is. But basically what I did is I went to a sketch. I had to rip up all the traces. I was almost finished this thing. I was just doing power, and I discovered that putting the volume knobs upside down, as I had them before, they were facing the other way, would mean that the notches are facing downwards when you're turning up and down your volume. So in order to have the notches face upwards, I had to flip all of my connectors 180 degrees. They're a little bit asymmetric. So I made a standard guide where I did a standard distribution of 8 objects, because that's how many holes I have, on the board, and then I had to do an offset for the volume knobs. I have templates for all the Euro rack sizes. Yeah, that's what I got in here. I made files specifically in order to do that. So you put in the number and then it makes the specific size. Any CAD program worth using can probably do that. One thing that really pisses me off is while all of the components are centered around 5 millimeters, they're English sizes. Some of the components are English sizes. The through-hole stuff is English. The SO parts are English, which means when you get something like this that's offset from the other side, it's going to not be symmetric. Is that symmetric? That looks symmetric. Okay, so maybe that one's symmetric. So why is then, I guess there must be an uneven amount of spacing in here, so that when I'm routing traces, it can be either a little bit to the right or a little bit to the left. And technically I can fit 3 in here if I really squeeze. Many of these were thanks to the route multiple traces tool. There's a tool in here for routing multiple, and you just right click, go over them, solid click down to select, then you left click and it'll start routing the traces. It can't do it for that one. So like, for instance, if I wanted to route these 2 together, or rather if I wanted to do all 4 of these together, Fusion has a tool for doing this. My grid right now is a metric grid. When I redid everything and I flipped them around, I redid, are you doing this on 4x4 mil? It's a 3x4 mil or something like that. It's whatever JLC PCB's 2D board service, a 2-layer board service can handle. Route multiple, select them, left click, right click to route, and then there are your traces going down. And depending on what type of curving parameters you have, you can manipulate it like so. We may use this in a little bit to do these guys. Because yeah, I could break volume off and take the 3 of these in. Yeah, maybe that's how I do it. All right, so that'll solve that pretty tidily. Although, yeah, volume and this one, the RL control, are going to have to come in from here. And I'm wondering whether or not I need to swap the amplifiers here in order to get these pins to make sense. I'm assuming the auto router is still bad. It probably is. Very clean work. I like how the traces are labeled. This is my own sanity. It's all my own sanity. And it's all coming from this schematic. This schematic, you got to think about this schematic as being this is not an actual schematic. I mean, it is going to be the final schematic of everything that you have on the board, but it's more of a working programming document that tells the router what air wires it's supposed to be putting in. That's what this is really all about. So you'll have things in here that aren't actually installed, like the mode select resistors on some of the chips. And then beyond that, with circuit board design, I actually kind of want that to be a little bit more even. I don't know if I'm going to be able to accomplish that. With circuit board design at the speeds of audio and analog, we don't really need to consider like meandering traces in order to keep them equal lengths and therefore equal resistances. You have two wires that are at the same resistance as you're pumping voltage into them to relay a digital signal at, unfathomably quick time. You can see the voltage going up differently from the two. You want those voltages to come up at the same time so that they get recognized simultaneously and your communication speeds can go up as a result. So what they do in motherboards, you'll see it often, you see these traces that are meander. They do a little squiggly line, hopefully canceling out a lot of the RF properties that'll be coming from that high-speed communication, but you squiggle the line and then make it an equal distance for the two traces. This will do that, this will meander stuff. We don't need to worry about that. We don't need to worry about RF noise. The only reason I'm using curved traces is because they look nice. We don't really need to worry about acid traps and all that weird stuff that sort of used to take up brain space as circuit board designers. We don't need to worry about. We're talking about audio frequencies here. We're not crazy high speed anything. So anyway, when designing a PCB, you start with your initial schematic and you put that down and you figure out what all of your components are. I can use these components versus these components. These will go here, these will go there. This is a general idea. Can I fit this all on the board? Will the trace layouts be super dense? Can I actually, yeah, RF boards are a lot of crazy, weird stuff, and then you don't consider one thing and it becomes a problem. Yeah, RF is crazy. But you sort of start gathering your pieces and you start gathering them together in one place. And you say, okay, I can put this stuff here, I can put this stuff here. What are the rules of the PCB house? How small can I make this? How dense can I make this? What does this mean in millimeters? Let me put that into the software's rules, and the software is going to help me lay that out. From there, what I do is I group the components together. I will group the components together off of the board in the free space to the side where the rules won't constantly be, hammering away at you. And what you try to do is you try to rearrange those parts to minimize the amount of these white wires crossing over one another. Now, we're in the sort of the end game for the signal traces, so there's a lot of crossing over going on over here. But you want to get them to sort of minimally cross over and get things in a logical location that you can then move into the board and get a better idea of what the interconnectivity of your building blocks are going to be. So I got this operational amplifier in here, got the resistors around it, and then did a sort of an initial trace layout to try to get everything connected together without going to the signals in other parts of the board. For that, I'm very used to viewing all of these air wires, but you can turn them off. You can right-click, put a line on a component, right-click and go to Properties, and you can hide the air wires. And that way, you can concentrate on one area at a time. And that's sort of what got me through this design. Getting the rules in there was a big help, but once you get all of your local connections on your components, you can then do the between sort of stages connections going. Once you've got all that worked out, it's then time to route power. I wait until the end to route power. Now, I did a little bit ahead of time over here because I figured I need to figure out what my maximum capacitor size is, try to get that in the very little bit of space that I actually have. Syphilid 8, sup, bother, 4 years, hot damn. Hey, 48 months, that's 4 years time, I know. Hey, I've been streaming for 9 years. 9 years soon, whenever my Twitch anniversary is. Baloo AU just got an anonymous gift. Anonymous, thank you very much. I really appreciate you. I don't know who you are, but I appreciate it very much. Yeah, I'm coming up on like 9 years of streaming. Insane, that's insane. So yeah, I because of the space restrictions, once I got all my big components on the board and I started to route the traces and say, hey, this is possible for me to do, I actually went in and did a little bit of power supply work, and that was just basically finding a maximum capacitor size because this board scared me. We were doing this and I was getting worried about this this audio amplifier. This is the same chip that we've got in that little QFN package. It's just in a larger layout, and they have a couple capacitors on this thing, and capacitors are unfortunately subject to physics and the limitations of actual physics, and so they're a particular size. So I could do what the one chatter was suggesting and have capacitors like this, but they'll lay flat on the back of the board. Like I'll just have them like sticking out the back of the board, but just be like parallel with it. But instead of that, I'm putting the biggest like small low to the board capacitors that I can fit. So that's the idea for capacitors. It's as much as I can do. I can't use tall caps because it'll get in the way of stuff. Let me close this. Well, we can push this to a 3D design actually. We'll take a look at this. I haven't been saving these. I really hope that board actually, maybe it'll come up as a recovery file when I open up the other thing, because I put a lot of work into getting the spacing right on that file. I think I have to recover it. I think my my computer did one of its funny little restarts that it does, where haha, Microsoft told us we have to restart. Hee hee ha ha. And so it did, and I may have lost that file. It should be in recovery, and I thought I saved it. Maybe it's just in a weird directory. I don't know, what would I have been looking into? This is taking a while. I hope this didn't freeze. Okay, there it goes. I really wish they could have that sync notification come up a little differently. Okay, so when I do the 3D render, we've got our minimal spacing here, and keep in mind I have to cut the leads on the header in order to fit it in. That has to be cut because that's not going to fly. So here we have all of our layers in and the traces. And the traces even have 3 dimensions. Neat. So we can assess our design and see what kind of stuff is going on. Fusion has not implemented teardrops going into the leads. There is a user language program that'll add them in, but I haven't really messed with it. So we've just got traces leading directly into vias. The teardrops help in production a little bit. They're not totally necessary because the machines are pretty good. But yeah, so it's not going to look too crazy from the backside there. The top layer here is going to look awesome because it'll have all of these sort of snaking signal collections going around it. But we're almost there, and then we need to do power. Power is going to be very difficult to do. So, all right, I think I've explained most of the process. The part that I haven't explained is the part that we haven't gotten to yet. All the stuff going forward. Basically, once I've done all of those signal traces and I've got that down, you then do power. Power can snake its way around stuff a little bit more. You don't have to be as crazy with it. And since we're analog, low frequency, we don't really have to worry about too many kinds of noise getting into the rest of our circuit. There are some better practices in order to reduce noise, but I don't really think we need to follow them that much. If I get the board made, take a look at it, and it's all noisy, I'll assess some of those issues. Our size constraint is the big one. Size is really what's making everything the way it is. Love how crazy you can make the boards look with KiCad. Now also with the liquefied traces and teardrops. Not topor level crazy. Liquefied traces. Does that mean that it's doing the curves like I am? The traces have 3D dimensions. CAD files 12 gigabytes. No. Had one colleague at some point exported a 14-layer, oh god, FPGA board with copper features in 3D. Oh, geez. Yeah. Oh, so liquid traces follows curves. That's pretty cool that they have that. Yeah, for me, I manually route the traces. The auto router can be a little bit crazy pants, and I think our size constraints are going to keep it so that the auto router is probably a little less effective than I think it would be. Although some people just throw it into the auto router and say, go. I could do that. I could just say, just make it work. Whatever, I don't care. And it'll auto route, and the traces will be doing crazy stuff. But I figure I want to minimize my signal paths on this thing. It says every opportunity to be as noisy as it can be. So I've definitely got decoupling caps by every chip, and I try to minimize the length of my signals, and we're going to be putting in a comprehensive ground plane. I mean, these are 3-dimensional. They actually have depth to them going into the board. In the past, what I've done is I've taken this body right here and 3D printed it just to get an idea of where all of my components would be, whether the slots work for my through-hole stuff. All right, so let's check in on my glucose level. Yeah, it's going to do everything it can to just gradually go down. It's here, better look at it. Yeah, I gave a huge bolus of insulin because 300 was an annoying number to be at, and now it's just sort of going to coast down from here. Okay, so anyway, back to work. So what we're doing is on this 2 Euro rack module, we are finishing. These are the last few traces that I have to put down. Finishing doing the signals coming from the potentiometers. Those are the ones that have had to travel the most to get to where they need to go. And I slunk them. If we view only the top layer, so if I go to my layer stack, I unview the bottom and the bottom names and the bottom solder mask, we're not viewing right now. This is what the top of our board is going to look like. I've got some power stuff marked out, but a lot of the signals that travel from one end to the other are on this top layer. So our traces are kind of getting together, splitting apart, getting to where they need to go, all that fun stuff. And I've managed to configure this spaghetti to get all the way up to the top of the board, where I've got only 6 that need to cross through. The potentiometers are 3-pin devices with 3 pins in a row like this. That makes it exceedingly difficult for me to get traces through. We've seen 3 fit through these, so maybe I can get 3 of these up to there, or I can drop a couple vias in, drop down to the bottom layer, and get through. I don't need your help with my diabetes. Don't help me with my diabetes. I just went out into the garage looking for something, and boy, did I come across a stack of books and crap from the past. If you have any questions about mastering the art of ICs, I have the book. That sounds like a fun book. Also, how to repair VCRs. Man, VCRs used to have a lot of stuff to repair in them, huh? Now we don't have those. We just straight up don't have VCRs. One thing that bugs me is getting these curves to be the same. It's been impossible to do, is get two of the same curves so that I can bump a trace over just a little bit to one side. I guess I could probably bump this down a little bit, or maybe just do a, I don't know if I can do a straight path on this one. I don't know if I can do it. But anyway, we got to get it up to the thing, so. This would be a YouTube short loop where Bother just continuously scrolls through the board and it never ends. Just scrolling through my board. So one of the features of Fusion Eagle, or I guess just Fusion is what I'm calling it. I got to look at that branding document and figure out what the hell I'm supposed to call this program. I'm so sorry, corporate overlords, that I've been misgendering your program by calling it the wrong thing. We don't have the hashtag on today, so at least that's, I don't have to be nice to them. I don't know what to call their program. This is Autodesk Fusion, so I'm going to call this Autodesk Fusion. So we need to get these traces through here. I think what I can do is the standard squeeze 3 through this end and then put 1 through the other. I like to view the bottom layer while I'm doing this because it can tell me where I can punch a via through and get to the other layer of the board. CADSoft is making sad noises. Look, I've got a whole document that tells me how to brand this. Route Multiple is a fairly useful tool. So I go to Route Multiple and I select using a line. They give you this little line tool that'll select any traces that it touches on the layer that you're routing traces. It does not do, top and bottom traces at the same time. So I can highlight these 4 traces, then I left click the mouse. Boom. That selects all of them. When I right click, it will start routing the trace. The thing about this piece of software is if I'm routing with a via, everywhere I point my mouse, it's going to resolve all of the design rules in order to put this thing together. So if I actually right click on this thing and I start routing this trace and it runs into stuff, it'll start pushing things out of the way in order to make sure that I can route this the way that I want to. Or it'll do crazy shit like that. That can crash the computer. Well, it can crash the software. I have to be careful about that. So what you want to do before you do a route multiple is you want to select the type of routing on that panel. Because I don't know how to change the trace bend with a circuit board command. But the circuit board command, or sorry, a keyboard command. Keyboard commands are down here though. So you can actually, hit the space bar to switch layers, hit 1 to do whatever decimal spacing is. Incremental space, the minimum spacing is really the one you want. Number 3 will give you your minimum. 4 is swap end. Okay, what does that do? I'm going to try it. Whoa! Oh, I see. We went to the other side of the... Wow, that tool really tries to resolve it in a fairly strange fashion, huh? So you hit 4 and it takes you to the other end of the air wire. Fugels, Fusion and Eagle users. Futile users. All right, that looks pretty even. So I'll take that, and I'm going to go back here because I'm going to expect to do another curve to get up and through with 3 pins. I could drop one a layer down, but I think I'm going to resist that, and instead I am now going to route multiple with 3 using the same curve. This time, try to get it. That's about as even as it gets, and that'll get me through to where I need to go. Hey, look at that. Beautiful. Beautiful. Then we got 2 traces coming in through here, so I guess I'm going to start with you. Not do multiple. Route, manual. Take this one up and through. So, I mean, this is just making things look pretty. This is just making pretty designs on my board. I could do this with a huge curve. Maybe we'll do that. No, but then I'll need 2 curves, and then it curves weirdly. So I think I'll do what I was doing with all the rest of them, and do just a nice soft 90-degree, and then come in up here, where you get 2 traces through at once. And you can just take it in little increments. Little increments will get you there. And then one of these. And it's just the combo of the different types of curved traces that give me my look to the whole rest of the board. But little tiny steps at a time will get you there. Gets you to your final design. Hey, what's up, Celia? Und Trey Pup. This is where things get crazy. So we've got a lot of crosses here. We've got a lot of crossing over signals. And so what I could do is rip all this stuff up, figure out, yeah, I'm just going to rip it up. I tried going the route of renaming things, but it just didn't work out for me. I can just use gate swaps in order to put these in the right spots. And then just keep in mind what the design is supposed to look like in the end. I don't know, it'll come up as something completely different when I design it again, but that's okay. So over here we have RL2 and RL2 knob. So RL2 and RL2 knob can go to pins 7 and 8. So we go back to our circuit and we go to the knobs. RL2 and RL2 knob can go to 7 and 8. So that's this one. So what I'll do is I'll right click on it and I'll go gate swap. We're going to go gate swapping. Bada bing. So now 7, 8, and 9 are RL2 and RL2 knob, which means here on the PCB, oh, it's done weird stuff with our traces. Little bits of traces that are kind of left over as residuals get juggled around when you do this. So this part of the circuit actually goes over here. Oh, we still got this thing. Click and hold, click and drag. If you go right to left, it selects everything that touches the box. If you go left to right, it selects things that the box envelops, which is important. That's how I can get these things and hit delete on them. You've been using Meshroom? I don't think I've used Meshroom. I used Mesh Tools or whatever. What's that one called? Remesh? All right, so moving these over here, giving them some room to breathe. It doesn't need to be totally spaced out, but when you get the circuit in, like physically, when you get it in the mail, there's always a little bit of like sticker shock around the size of all of the components that you've selected. You go, holy shit, this is a lot smaller than I thought it was. Stop juggling my gates. What's up, Celia? Do a beard brush attack. I brush my beard, but it doesn't listen to me. This does not listen to me in the morning. It does kind of, or get it a little bit better. I wake up, I look like a hobo. I still look like a hobo. I look like a prospector. But I try to brush it just straight down. All the hair on top goes straight back. All the hair on the sides goes down. This is deceiving. I have a huge freaking mullet in the back right now. I need to go get a haircut. I need to schedule that. It's, you know, it's the temperature has gone way down in the Northeast. We've got all that Arctic blast coming in on us, and so it's made it so that I'm kind of like hunkering down and doing a lot of computer work, a lot of circuit design. Perfect season to be doing circuit design and looking like a Sasquatch, because then I don't have to interact with people. Although I guess I have to interact with you guys. I need to find like a position that'll take advantage of the fact that I can do this kind of work remotely, where I can make a lot of money. I don't know how you do that. I really don't. People don't really need to get their circuits designed all that much. God, it would be a perfect position. People who design PCBs can make a lot of money, can't they? I keep hearing about that. Oh, we need to make sure our loops are not destructive. Because to put these vias in, you know, we need to start it somewhere. And sometimes that means two traces will go on top of each other. And luckily our software is smart enough to know that if we have two traces on top of each other on the same layer, it'll just combine them for us. You guys aren't people. All right, that tracks, that tracks. I stand by my statements. Nice and neat. Although I don't like that a lot. It's just we're at a stage of this design where I don't have to care about that. These, I guess they're in good places. Our volume is going to have to go, well, these two go to the next stage, don't they? No, these, oh, this one and this one. So yeah, it would make more sense if this one was the next one. So we'll swap the next two, which are going to be this and this. So gate swap, change places. I cast gate swap. Oh, get rid of this. And then our empty gate is still the upper left, which is fine. That's a good place for it to be. So we get these and we'll bring them up. They're those little pieces of traces inside of stuff. Wait, did I move that? No, we're still good. We're a maximum of 10 millimeters for this because that's a Euro rack sizing. This one goes down here. That. This one down. Oh, no! There's that error. So this error is insidious. This happens when you're dragging traces around and your mouse ends up trying to put the trace in an area where Fusion can't resolve how to move this stuff around. The way to get out of this is to hit escape about 65 times and then it'll eventually right itself. There's a little piece of a trace that was left in. Because it's evaluating the position you drag it in against design rules. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. I don't fucking know. I don't know if it's actually centered. Like that. So we're out a little bit more. There are actually arrangement tools that I could use for this. What? Oh, cheeky bastard. There we go. So that should be an even single decimal point number. 7.7. Good. All right. Control Z, well, usually doesn't resolve that specific problem. I put the mouse somewhere neutral and I hit escape a bunch of times and it manages to not crash the software. It is very annoying. So this one I can take out just a little bit. Oh, wait a sec. I want to rearrange these two. That's not going to be good because RL1 comes in over here. Volume is here and its cohort is over here. So these two have to go all the way up, while I can actually route this one on the bottom layer. I can just keep this on the bottom layer. So let's get this into a similar layout there. And this one, why is there this big label sitting there? Oh, because I guess I named... Yeah, that's just the name of the trace. Okay, go. And then this one. Oh, that one's off too. What happened to you? The CAD program doesn't care if you've got just batshit insane numbers on the positions of your devices. So I have set my grid to be 0.1 and 0.01 grids, which is it gives me a decent amount of working ability on these things. You know, these QFNs are metrically spaced. The through holes are all inch spaced. Although I think the thonkies are kind of mostly based in metric. Yeah, the thonks I think are, but the SOs are not. So they will be not centered properly and things will be weird numbers. And then if you accidentally, you know, working on the grid is supposedly an outdated thing for like mechanical design, but for electrical design, the grid is still pretty relevant. It's nice to have everything on the grid because then your trace layouts kind of make a little bit more sense and things run into each other a little bit better. But the CAD program sure as hell does not care about the grid. And these machines that are making the devices don't care about the grid. And so you can design things with absolutely insane position numbers on them. You can have 2.1573964 millimeters, and that'll be meaningful for some reason. It really helps to take into account what that spacing right there is. That is 0.1 of a millimeter. It's a tenth of a millimeter. A millimeter divided by 10. 0.1 of a millimeter, 2.47, 2.48. Barely even by touching the caliper. It's like nothing. Yes, it's all a Tron reference. The sacred grid is very important. All right, so I'm kind of getting these into shape. I can drop this one to a via. Oh no, I can keep this one on the underside. So let's route that a little bit. That is technically gonna jump up as a design rule error because I didn't fully connect that. There's a little tiny air wire inside of that. I Control Z, take it back a step. What I need to do is position this over top and have it do the green X. That's going to connect the air wire and count as a routed trace. There's our pot connected. Now I just have those two and this one coming in on it. So if I minimally route these two in this area, I can use curved traces. Actually, we can pull this volume back a little bit. I want a little room for a ground plane there. So I'll pull it back only a tiny bit, and then we'll give it a curve to the left and then to the right. Actually, I could probably do this more fluidly like this. And then we can encourage this one into the same spot. Like that. It's a little weird. It's a little clunky. And maybe it needs to move over a little bit. Oh, that's going to run into some trace issues. Move it back a little bit. Oh, no. In order to do that, I need the problem is selecting multiple in Eagle is tough. Fusion, Eagle. Pull that back to there, and then I can do, well, this is the one that I need to pass by. So if I try to route that there. Now, technically, I really could do a pad on the surface mount pad. I've tried to avoid it because I haven't figured out getting rid of the solder mask layer stuff. I find your stuff a little mesmerizing and I'm trying to work. Sorry, dude. There's something special about this. What is 2.48, 2.54 millimeters is 1/10 of an inch. Yeah, it's crazy. This having the grid set up and routing the traces is actually a lot of fun. It's like playing Factorio. It really kind of itches part of your brain. It itches an itchy part of the brain. And you're making all these same little decisions that you make in these factory games. So I need to get these two traces. I really don't want to cross over this. I do wish I had a method of getting RL1 in there a little bit more cleanly. But a lot of these, yeah, there's not a lot of options. Go around the outside, around the outside. I guess I can just do a sharp turn right here because V negative is the op-amp's interface with the ground plane. And so there need to be vias there that'll bleed off a little bit of the heat of the chip. It's not a serious amount of heat. They don't really necessarily need heat sinks, but it's nice to have. Remember, if your brain actually itches, you might want to see a professional. No, you scratch the itch. You have to, because it's a brain itch. That's what my doctor said. Inconsistent. There we go. My problem with routing this board is that the consistency is killing me. Everything has to be perfectly consistent in a special kind of way. Okay, so routing traces. See, this is coming from an inch-sized pad. No, that's centered on the grid. This pad is inch. The resistor pad is inch. And its center isn't centered on the metric layout, which is what a piece of annoyance that I've had to deal with the entire design of this, is that these resistors are inch pads that aren't centered. I need to fix that because that's like a systemic problem in all of my boards. Are there any rules of thumb for placing vias? There are lots of rules, but a lot of them don't make any sense in the boards that you may be making. Wait, where did what the? That's not supposed to be. This is supposed to be the top one. No, that's correct. Okay, sorry, brainworm. There's a lot of rules to laying out PCBs. There's a lot of better practices, and if you really want to read a lot about it, check out one of these board making houses. They'll advise you on all the things that you need to do in order to lay out a PCB, but a lot of it is not necessary or required. You will hear a lot of snake oil being talked about in routing PCBs. People talk about, oh, but the RF pools in that area, or this is a solvent trap. Solvent is going to be caught here, and it's going to. No, it depends on how they're making your PCB, whether or not you need to do those things. Now, there are nice things that you could do that'll help your PCB be easier for the board house to create, but there's not a lot of rules in there. A lot of them are just how you deal with your ground planes and how you deal with like corners and stuff. You don't have sharp corners on the board. I design everything with curved traces and I make it as soft as possible. That's like, and at the speeds that our electronics are operating, they're not high speed digital, so we don't need to worry about the effects of RF on a corner. We don't need to worry about traces that are equal distances and stuff. It's when you really start pressing the envelope that you need to worry about these kinds of things. This is a prototype. This is a one-off at the moment that I don't even know if I'm going to sell in the end. I'd rather run into those problems in the field with a board in my hands than worry about all these things simultaneously and have that sort of breakdown of the executive function where you're worried about so many different parameters on a board that you are unable to make a decision. You throw the trace down. If it goes, it goes. We only exist to make beautiful artwork out of our circuit traces. Wish KiCad had curved traces. They've got liquid traces, right? Weren't you telling me that earlier? Don't they do liquid auto route? I'm going to stand up for a minute because my butt's raw. I've been sitting on this 1960s stool for hours and hours. This is why I have standing height desks. So I'm leaning into the desk right now and stretching my legs. And you guys are none the wiser. Other than that, maybe I'm like an inch taller on the board, on the screen here. Yeah, so I mean, a lot of the stuff I worry about is um, just purely visual. There are some best practices that you can do, like having vertical and horizontal traces on your two layers can help you route a little bit more easily and a little bit more brainlessly. In addition to that, you can also kind of think of the engineer that's going to have to put this thing together. How can I space things out so that I'm not going to have solder bridges? How can I space the components so that they make logical sense? Where can I put test pads? Vias are also test pads, so I generally don't worry about that too much. And I guess with what we're doing, we're not really worried about power taking too long to get there. You know, plus minus 12 volts is quite a hefty supply, and I think it'll have no trouble at all getting to where it needs to go. I kind of want these to center on these two, so I'm going to rip these up as they are at the moment. We'll see if we don't get a symmetrical entrance. Excuse me. Try to mute those. Do they have to cross over? That's very annoying. How can I get them to cross over? Let's see here. Let's see which strategies. I guess I'm going to come from this corner. Oh, that's right. I went directly over like this before. We can move that over a little bit. Off grid, off grid. Guards, guards. So that's a little close, and I think the rule set that I put into this didn't really cover curves like this. The JLC PCB didn't have a specific parameter for curved pad, and there probably should be. So this is probably in violation of the rules, and the software is unable to reconcile that. Let's move this around like that and get enough room on the corner of the board. I do want to chamfer these corners and make them nice soft. What's going on there? Why doesn't it allow me to get any closer? Oh, because I'm manipulating these traces that are inside of the pad. So get rid of those, and we're just going to move this in a little bit. That I don't like. I think those are too close to one another. It's going to make that impossible to solder. So I'll push them out just a little bit, keep them away from the curve, push this in a little bit. Maybe just a little bit there. I think that's maybe has gotten us back to our original position. Take this back up, do a curve over to there. It's a little bit further away. I would like it to be a little further than that, though. So I guess I will just push this out to the edge a little. I don't want these too close to one another. I think that's going to be a horrible solder bridge. Maybe not, but it's nice if I think about future bother assembling this thing. See, what that curve does is it just kind of mirrors this one. Oh, oh, nope. That's got to move up. Oh my God. It's not a perfect piece of software by any means. What? It just deleted every, what? I want this to go down one. In OG Eagle, there was a way to select just the ends of the trace. That was a bit more effective. But I guess they don't have that anymore. That, or I just don't know how to do it. Remember, we fight against misinformation on this channel. Any misinformation that you receive is purely by accident due to my ignorance. Oh, why does it have to come in between the two? I could do that. That doesn't seem very good. I have to do this. I have to. The curve traces demand it. Why is that so uneven? Oh, it's because of these stupid pads, isn't it? No, I've got three in the middle there. They come right up to the edge too. That's interesting. I guess one of these is off by a bit. No, they're the same. It just looks lopsided. Oh, because there isn't a center. I see. Was moving this thing over one a disaster? No, that actually. Oh, back where we started, huh? This one can go this way. Oh, that makes me. I need to do over one. Ooh. Okay, that looks okay. Copper to copper is likely always 3.94 mil. So whether two copper points in the Gerbers match, it will be flagged. Nope. The rules are totally different for JLC PCB design. You got to look at the JLC PCB design rules. That's what I've set everything to be. Although if the default value is 3.94, then maybe it'll still get flagged. I don't know. We haven't done an official design rule check. It's just the design rules that are in the CAD program right now. So I have the two connections here. That is a hard wall that we can't get around. I can arrange them a little bit with the vias, but one needs to get all the way to the other side of the PCB. I feel like I could drop that one down here and go up and around, but I guess not. I suppose not. Would a gate swap make more sense? No, because I can't get RL all the way up here. And I can't swap them down here. They sort of naturally flow into one another. I could pop some of these over to the other side maybe, but RN2 is actually in a precarious position too, because that's a little too close to the edge of the board, because we're going to have to put milling layers on the edge of the board, at least for the next revision. Those two I can squeeze up here and get them over to this side. That would mean volume could go. Okay, so let's get them together. Let's get our two little signal traces together here. I wonder if I do a multi-route on these, if it'll do the traces for me. No, it'll do those three. Hold on, wait a sec. No, I think I need to move them a little closer to one another. Myself. So let's do this type of curve. Come up here, we'll make it one of these. I'll come up probably to about there. Same thing here. They never end up even. They never end up even because I have no self-control. Yeah, see that one? Okay, so if I can get this a little bit even, it's never going to look right. I wish I could cut and paste the features of one line into another. God damn it. All right, so they're never going to be even. The one's got to take one for the team and be weird. Route multiple. You two coming with me. Whoa, okay, that doesn't, huh? Are they too close? Is that what's going on? Huh. Route multiple. There you go. It's just software got confused. All right, so I'm avoiding the front of it. Whoa, why is there so many? Huh. it's like it runs into issues with that. Okay, that. We're coming over here. And then I'll go to Avia. So this one I'm going to have come down here like this. Oops, that's route multiple. Need to switch tools. One of the big things with Fusion is that when you use a tool, it's not going to bump you out of the tool immediately after using it. It'll have that window up there. You'll ignore the fact that the window's up there, and then you won't realize that you're still in a tool. For instance, if you're locking and unlocking the positions of things, I was doing that a lot earlier, and what would happen is I would lock down something and move on to another part of the drawing, and then click on something, and it would lock that too, because I didn't hit escape. This is originally a command line software. It still is a command line software. I have a command line right there where I can type in commands, and that used to be how you would operate with Eagle. Is you would type in the command and then hit enter and put any parameters in the command into the command line, and you would control things with like arrows and positions and stuff. There was a lot of writing down of coordinates going on. One aspect where I absolutely love Altium, copy and paste copper features, and they auto-assign net upon pasting. God, that would be so nice. I don't know if there's something like that in Fusion. There might be. There's a lot of features that I just like don't know about. See, I could put that here. I could put it out here. Doesn't matter because I'm being blocked. I'm being knob blocked. This is going to get real ugly because it's got to do a right angle and pull itself over to there. So I think what I'm going to end up doing is we're going to rip up this part. Pyro! Hey, Pyro S, subbing for 71 a month. I appreciate your continued subs to this channel. I really do. That's what Prereq used to do. They used to say it real sarcastically, and I don't know, whatever. But yeah. So I'm going to try to go up and around this, I guess. It's kind of annoying that I have to do it that way. There's no other choice, really. Because otherwise, it can either go in here or it can go in there. That's not really going to save me, though. This has helped, having this be on the underside of the board. This is the easier part to lay out in the board, by the way. This is I kind of got to the end of last night, and I was like unable to make any decisions out here. But there's a lot less stuff here. A lot of the decisions in this area were multi-hour layout decisions. This, I will never reconcile. I'm not going to soften up these turns anymore. I can't do it. I just can't do it. I spent hours on this part of the board, and this is what it's going to look like. It's going to look a little bit inconsistent and weird in this part. There's nothing else I can do for it. I wish I could have it be a little bit more liquid because it doesn't really need, it barely needs to move in order to dodge that. And I can't move it in because that's the minimum amount of space that I have right here. And then I've got all these traces that need to move through this area. It's possible that I could knock them over to the left a little bit more, but that would just exacerbate some of the inane routing that's going on in this area. Been a while, but the last few months kind of threw me off of my routine. Hopefully I can join the stream often from now. It's no problem. It's no problem. I appreciate anyone who can make it to the stream. We've been solidly working on this mixer circuit. It's been my sole focus. When I'm done this, I'm going to have a lot of information that I can then take over to the design of the module testing module, burn the subs, etc., etc., etc. I'm sort of rekindling my love of designing circuit boards in the wake of cheap circuit boards. I hope this mixer will work well. It's certainly got a lot going on. Now, if I stack those one on top of the other, I guess it would fit a little bit better, and that would be something that maybe I could take to a decision. I can move all of this stuff down to the degree where I have room to put two resistors on top of each other up here. Possibly. Or I could just try some other strategy to get this thing over to where it needs to go, which is probably just going to be a very circuitous pathing. Put that there. It's a little close to the ground, but at least we get that done with quickly. And then this one out. I'm doing them out to a via. I really don't think I need to, but that's just how we're doing it. This can actually move all the way up here then. And that'll give better ground access between these two. Yeah, I wish there was more clientele or more access to clientele. I don't know how to get clientele when it comes to laying out traces for PCBs. From what I hear, if you do get a good hookup, it pays great. And if somebody really loved my methods, I would love to get paid great to do this kind of stuff. But I looked at it as a career. I asked some board guys, like, hey, where do you, like, you know, I was thinking of going into this. And they're like, don't. I was like, thanks. All right. I guess if you do it professionally, there's a whole host of things that you need to worry about. This is just a diagonal drag. I can click and drag diagonally to change the amount of curve. And then I cap it off with a straight line just to make it look a little bit more natural. So you don't have like a point on the thing. You want those nice soft bends. You don't want points and jagged edges. Although this technically counts as like a jagged, that's a little bit of an inside bend there. There is a ULP that I could run that supposedly does teardrops for all of these, but I don't know how well it works with curved traces. As a fellow board designer, I have to agree with that advice. Damn it. You know, I have this whole host of skills that I have sort of curated for my entire working career. Ever since I was a teenager, I've been doing this stuff. And I don't really know where it actually makes any sense. You know, rapid prototyping is and all that. This is actually wrong. Oh, it blew up. Went the wrong way. These are off kilter from one another. Why do I have an eye for this? Right? Alternate spacing. Can I? Why do you hate me? Here's what I can do. I can go to layer stack. I can unview the top layer, blow both of these into the water, and just redo them a little bit more symmetrically. Now these aren't going to line up that way, so I've got to come from the other side. I'm going to come from here, and I'll just let the software figure out what the curve should be. That looks a little bit more even. Wow, there's so much working space. I have so much room to look at my design. I've had several times when I've asked for genuine advice and I've gotten, don't do the thing. Just don't. When I'll hunt for a book of schematic projects that I've had for 45 years. Holy shit. We tried to do that with the big damn book, the big book of circuits from the 1970s. It turns out a lot of these published circuit books aren't giving you a lot of information about what the hell's going on. This looked a lot more even when I did it before. They really don't give you a lot of information about what you're getting into with these circuit books. They don't give you a complete anything. They're just like, here's this circuit that I did, and I'm going to keep every single facet of it secret. That looks even, right? And this goes to here. But yet those are uneven. Those are... Oh, because these are... Oh, they're... Oh, I see. Okay. What does that mean? Should I... The spacing of a singular trace versus two, they're off by 1. But they're symmetrical around this one. But the spacing in between them is uneven. And so it can't be even. Oh my God, my head. Half of the design was obfuscation. Oh, whatever. Just here, sort it out. Oh, but then that one goes for like a really short bend. Oh God, oh God, it's uneven. It's uneven, it doesn't look even. Ugh. Color organ. I've heard of them, I don't know much about them. I have these old vacuum tubes that are like magic eye displays. I would love to get those running on something. 4-channel color organ project with the 4th channel was a master control. Ah, seems cool. Built 2 of these color organs, and they were basically breadboard kind of projects. Then we made circuit boards the old-fashioned way. I hate the old-fashioned way, I really do. Some of the cooler ways to make circuit boards now, if you really want to get into that, is you can get tile cutters. And a tile cutter has a little V-groove in it that you can use to make a little V-groove in the copper. And so you could make a layout just by, by scraping it. But the old way of making a circuit board with like your teenager is to go and get etchant and an etchant resistant marker. And you design the whole circuit board, and then you use the marker with a stencil or just freehand that mofo in order to make a mask where all the traces are. And then that marker masking everything, you put it into some horrible chemicals, and then it etches away the copper. And you don't get a solder mask, you just get bare copper. Yeah, no, thank you. No, thanks. I'm going to send this thing into a service and get 5 of them for $5. And they'll have silk screen layers, and they'll have vias, and they'll have, you know, all the fun stuff on them. So we did it with our special trace tape. The etching material would not eat because it's not copper. Yeah, it's stuff's horrible, though. Doing just layout professionally can be a pain because there's a lot of information on the schematic that's not always written on the or communicated. For freelance, what is that I just hit? Oh, I hit a dimension tool. Weird. For freelance, if I would go back, I would still do full projects end to end. Yeah, doing the projects end to end, I guess you're right. Having all of the information and being able to act on things and fall back and change things when, you know, like, oh, this layout's not going well, maybe I'll use a different chip. That kind of thing is nice to have at the level that I'm at. And you don't necessarily get that if you do board layout as a professional thing. So this is a keep out area. This little circle here is where the Donkey Kong connector apparently doesn't allot for the height of the 1/4-inch plug. You're technically supposed to have a 3mm hole here. I'm not going to do a hole in the board. I'm just going to do no ground plane in this area. So that does it. There are no more air wires, but yet not so fast. Our positive and negatives have not been laid out. So I have positive 12 volt, I have negative 12 volt. I now need to get that onto this board. What I'll do is I'll find somewhere that I put a trace down for V- or V+, go to properties, and I'm going to unclick air wires hidden. So now we have the positive and the negative air wires visible. We could wait to do ground. We could wait to do ground because ground is going to have access to a lot of ground planes. So ground might be much easier for us to get to our destination. The old way, back in my post-communist country, there were no sticky markers. I laid out my first PCB with nail polish like the real mofos. Holy shit. I mean, I would not use the chemicals. If I had to physically build my own PCB here, just so nobody else, to use oscilloscopes make any sense, or it's better to get new? That's tough. That's a tough question because the new ones are not necessarily going to be better in a lot of aspects, depending on what you're going to use them for. The technology has made it so that LCD screens and processors and stuff like that are so cheap. So you can make anything into an oscilloscope. You can make a really cheap handheld oscilloscope. So you could buy something for tens of dollars, and you could get yourself something that will allow you to troubleshoot electronics to a small degree. When you get into the higher stuff like categorizing signals, decoding things, and really getting into like high-speed digital and things like that, you may want a real oscilloscope. Or maybe you want the features that I have, where I have the OBS. One of my OBS inputs is just the intranet site that the oscilloscope has, because it's a touchscreen Android device at this point. So it's able to have a remote desktop where you can click on stuff. And so I put that up on OBS, and I get a 60 FPS representation of my oscilloscope. You buy an older oscilloscope, you're not going to have those features. I have an expensive Rigol DHO 914. I bought it about a little over a year ago, and it's been amazing. I have not unlocked I think I need to unlock or enable or something, the digital thing. You need like a certain cable for this, and I don't know if anybody's hacked that yet. But in your own purposes, you might not need something that even touches the features of this, the one that I have. You know, I'm doing this stuff professionally, so obviously I have to have a good oscilloscope. If you're troubleshooting like an Arduino project every now and then, you don't need the super duper oscilloscope. You can buy like a super, are they really $650 now? I bought mine for like $1,000. It was like $900. Rigel DHO 914 on shopping. Oop. I'm gonna cough 1 sec. Oh God, there's $600 and $700. 500. Oh, that's the other model. I could have saved $300 by waiting a year. Why did the price drop so much? Oh my God. Maybe because they were brand new when I bought them. Or if people learned about how terrible they are. So, okay, we're at the point where we've got to get V plus and V minus to all of its respective nodes. Ooh, hold on, I'm hiccuping a little bit. Major heartburn. Woof, that really hurt. So when I route power, I'm actually going to route it with larger traces. It's like my HP, once those digital inputs are an input pin and ground vertically. Nothing fancy. I don't know, because Rigel, it does look like just a giant pin header, but you may have to have specific pins in order to get it to work. Used what for etching? No idea. Those chemicals are horrible. I'm still going to do the thing with the vias that I've been doing all along, only my traces are not going to be 0.2 millimeter. I'm going to make them 0.25. I'm going to keep it in like standard millimeter sizes. I could go with the wackadoodle sizes that they want you to route in, the English types. Look at this. It goes to 0.2032, 254, 3048. I'm just going to make that an even metric size. 0.3 is a little bit thick. 0.25 is a nice big trace. This is what this looks like. Here, this is a nice meaty trace that'll get us all of the wonderful current that we need in order to run all this stuff. So take that to a via, and basically we're going to be taking it, walking it down. It's got to go all the way down to these various nodes. Not easy to do. This is not going to be easy to do, especially given that V plus seems to be jumping around the whole board. How the hell am I going to do this down here? I have to come in from up here and maybe do a via out towards the edge. We have some DHO 1104 scope at work. Sorry, very sorry, but I hate it with a passion. Buggy and sluggish, and the damn thing freezes if you save too much to a USB drive. Com.Android stopped working and it all blacked out. Oh my God. I've had good experience with mine, except for the fact that it takes a full 54 seconds to boot up. And the intranet site being a control for the oscilloscope has been a wonder for me. I've got it plugged into Ethernet. I press the button, I wait for it to boot up. About a half hour later, I'm into my scope. I can hook it up to stuff. I can get a good signal analysis going. And if I want to change stuff, or if my boss wants to look at something, they can open up an intranet site and take a look at what's going on. I find that to be extremely useful. We should probably make these into larger traces, but the transmission of the power really should be relegated to that size. Now, I've done a lot of work on this thing to cut myself off, to cut myself into pieces. This is my last resort. How can I get from one end of this board to the other when I have both of my layers working directly against me in that regard? I can smash this volume line all the way up against the via and come through here like a tank and just blow away all this stuff. I could take volume from the top, drop down to the bottom, and then go over to it. And then I've got a straight shot, at least to this open area right here. But then that's going to cut off my ability to run V minus, which is crossed over to the other side. And I refuse to flip the ICs. I want the ICs to have sort of the same position on all of the locations. That way it's not confusing. But it sure would be nice if my minuses and my pluses were flipped on these. It's the volume control that is unfortunately dictating where this plus and this minus is. The volume control makes it very difficult. I need to have it so that when I turn this knob all the way to the bottom, you turn it all the way down, and then these two are connected to each other. And because it's going into an inverting amplifier, that means that it needs to be at positive 600 millivolts. And when you turn the volume all the way up, it goes to negative 3 volts, 3 point something volts. That's done with these resistors. It's adjusted by these resistors, but that means that my pluses and my minuses are on the wrong side. Ay, ay, ay. If I reverse the resistors, I could use smaller traces and go to the opposite. This is crazy. If I did a 4-layer board, obviously, I'd have all the room in the world to bus power up and down this whole thing. Used to use it 20 years ago in school with the teacher's supervision with no PPE. That's crazy. I don't know why. Well, 20 years ago, you could still buy like a desktop router and do it with that. The tools didn't really exist as much as they do now, the real good tools. Well, this one, V plus is kind of easy because all I need to do, actually it isn't, wait a minute. If I can bump this to the side a little bit more, and then I can reach it. So let's do, instead of this one here, I may still need that one there, but what I can do is I can take this guy, and we can move them down a little bit. You down. Whoa, whoa. Whoa, whoa, whoa. Okay, so that one's sitting on the end there. Don't need that. Bring you over. Actually, we can tighten these up too. Because now, that, go here. Why? Why did you do that? Why? Why was it doing that? It's like insisting that I have a curve in there. Look at that. It doesn't. No, 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 you can't. No, no, you can't make me. No, stop it. Why is he doing that? Why are you doing that? Fine, we'll move away a little bit. Jeez. Why is it so stupid? I laughed myself into a cough. It's really dry out, and so I've had this like post-nasal drip going on. So tomorrow we're going to hack light bulbs. Oh, you know why it is? I know why I was doing that. I changed my trace size. I was trying to lay down a 2.5, whereas I should be laying down a 2. This is going to happen a lot as we go through the power traces. And then we want one of these just to look good. All right, so now, now I've got V plus on this side of the big wall, even though it's going to have to switch places again when it gets down here. I could anticipate some of this by stretching the traces out, but yeah, this kind of layout is just, man, it's annoying. Ours had one of those fish tank heaters in it. Yeah, it's a fish tank heater, and then you get the bubbler so that you get a little bit of movement of the liquid. I've heard of all those techniques. You got to heat it, and you got to do all the... If you do it right, you can make a decent circuit board, but it's still really bad. I don't, like having all that chemical, all the horrible chemicals that you need in order to make PCBs. That was really the worst part about it. Yeah, these power traces are going to have to do a lot of acrobatics in order to get from place to place. For instance, how am I going to get down? Oh boy, how am I going to get down with V+? I can go on the other layer of the board and come down through here, and that'll get me about here. Don't know. Ugh. I don't want to min-max this, but I don't think there's much room for that 2.5 trace to get through there. So what we can do is, and in order to just make it totally transparent, I'm just going to come out here and drop down, and then I'll go down here. Yeesh. Big, thick traces. So much for ground getting around, huh? Surely that's not going to fit there. Yeah, it doesn't. Womp. Womp. Where are we going? We're kind of vaguely going in that direction. We're blocked here. But if I jump over to the other side of the board, I could move this over here. See what that does. All right, so this one, and whatever was going on the top layer that's now a little orphaned trace. Okay, so nothing. Bottom layer, this one still goes directly over to here. However, oh, that's the wrong size. Because I can get here, I can move volume up a little bit, and then we'll come down over here. So we're going to do 2.0, 0.2 rather. And then I'm going to bust this thing out. Oh, no, no, no. Out of this corner and down. Oh, I have a trace sitting right there. Well, I didn't notice you there. You start to, the little decisions that it takes to put something together like this start to really run into each other at a certain point. Okay, they're both off grid. Trying to move over N18 to try to sneak in. To the power trace. All of this and more would be solved by going to a 4-layer board, because then I would just have an internal routed signal that would get me to where I needed to go. So the soonest that I can do this is here. And then that goes in there. Oh, the little pieces of traces. Bottom layer, route a trace, up like this, into there. And this one goes across somewhere into there. Then volume moves up a little bit. So we're going to grab this stuff. Up and up. There we go. Let's tighten that up a little bit. Looks all right. And then I think, well, that's about as soft as it gets. I can soften it up a little bit, but that doesn't really get it totally out of my way. Getting a via in here is going to be tough. Bring this back, go back to our 0.25. This is the whole process, and the reason I haven't been reading chat is because I actually want to get this done. And you guys can see some of the actual decisions that are being made here. So we do this kind of bend here, and we're just getting into this area. I'll get as close as I can to this one, and then drop that right there. No! Ah! Okay, I understand. Not enough room. Softer bend on volume, and maybe I can get it more fully out of the way, and then maybe RLN1 can move over just a little bit. So I'm going to bring that out and then select all this and just jiggle it till it fits. This is, I don't like this where I have this here. Probably should fix that somehow. All right, so that's there. I can now try to avoid it with 0.2. doesn't cause any conflicts. I think I can move this stuff back over just a little. Why? Just like that. I don't like this at all. I think this could be a little bit more elegant, but with that via right there, I don't really have much choice but to tolerate it. There's no other place for that via to fit. But now I have free access on this layer with a 0.25 to get down into here. Oh wait, that still has to go up and around. So, oh, this is way too close to the chip. Let's go like this. What up, Gonad? Making little tiny micro decisions, little micro aggressive decisions. And all of it is in service of just looking good. That's it. That's all we're doing. We just make it look good. And look at that. We've gone through all of the decisions that I just made, and all of that little kind of rearranging and refiddling and just getting things to just barely get in the right spot, and that gets our V plus into the right spot. Woo! And I've got to do that with both of these constantly snaking around each other, going from the top to the bottom layer. This is going to be very annoying. And I'll probably have to put a little bit of extra material up here in order to make sure that the V negative gets a heat sink, because that's essentially what it is here. I need liquid. I need liquid. Do I take a sip of the Red Bull? Do I dare? It's a sugar drink. I'm micromanaging my decision making. Yeah, there you go. It is a lot of stuff to hold on to in the brain pan. Looks like my glucose level's going down, but if I take a sip of this thing, micromangle. They're micromanglements that allow you to have soup brain. Ugh. I don't like blueberry Red Bull. Blueberry's a nice flavor, though. So if I were to place a via and I called it V negative, can I place it and have it? Let's do route and do via. So look at this. It's so dangerous, this via tool. It just knocks everything out of the way. That one's going to make two. It mangles your design as you go through it. Ugh. I specifically told it to solder mask off, and yet this layer that we're looking at here, this stitch layer, the white stitching, solder mask top. I may have to contact them about that, because that is a huge issue. Via signal name V negative, auto size, via shape is round, solder mask off, auto or offset. What does auto do for me? Does that actually turn it off? No, it does not. So I'm forced to put these here and then probably go back later and delete the solder masks. That should not be there. I have it set to be off. Mark Forged has 3D printable copper to make future. Oh, no. We watched the, we didn't watch it. I don't do watch alongs here, but the Project Binky Grassroots Motor, or not Grassroots Motorsports, the Bad Obsession Motorsports, for their gauge cluster, their dashboard gauge cluster, which, by the way, I would not go the route they did. I think it's really cool what they did. They did a lot of very cool stuff. They made a very interesting gauge cluster. You can just buy a gauge cluster from another car. If you find a gauge cluster you like, you can just buy that. You can just put that in there. You don't have to DIY your whole gauge cluster. And then there's stuff like the Race Pack gauge cluster, where it's everything you need to be on a gauge cluster in its own little system. Many different options for doing that. They decided to do none of that and do this complete fabricated dashboard. And what they did is they actually used they used an FR4 board, and they had a 3D printer whose nozzle was fed solder, and it was able to put down sort of a high temperature solder. None of the off-shelf bits matched, so they made it all. You could just buy something. You could find like a physical cluster that has little gauges that you can take over with the CAN bus. The amount of fiddlery that they did with the Arduino could have been done in a different direction. I don't think their 3D printing circuit board thing was a great idea. They came to it in sort of an organic, natural way, so they probably didn't see it at the time as being not a great idea. The amount of money they spent on their 3D printable PCB was probably similar to going to a board house for 4 or 5 different iterations of a design. You don't see it at the time, but there's a reason that the methods are the way they are. But the other thing, and this is something we were talking about in my Discord, I would love to get a gauge cluster from a car. There have been projects where you take it over with an Arduino, because these Arduinos, they speak CAN bus now. And so you can take it over, you can speak to it in CAN bus, and you can get all the little twiddly bits to work, including the check engine light and all that stuff. I would love to get like an E46 gauge cluster and use that. But yeah, the the layout of the gauges that they had, I'm sure it's a little different from what you can get in a consumer car. My route to that problem would have been to have an Arduino as an interpreter of all the different car systems. So talk to the car systems, figure out what the things to implement on the gauges were, and then speak CAN bus to the gauges. That would have been my solution. But I'm not Bad Obsession Motorsports, and I'm reminded of that constantly. I'm constantly reminded of my shortcomings. Back in my day, Arduino barely spoke RS-232. I know, they've come a long way. They've come a long way. They're very capable little bastards, these guys. I still need to fit, and I've sort of partially cut off a nice little avenue there, V- into all of this mess. V- still needs to somehow travel down from on high. And it also needs to reach this over here. This is pretty much a straight shot. It's a sure shot, sure to make your body rock. Let's come in from... Whoa. Aw, man. Stupid volume knob, messing up all my plans. I don't really want a via this close. I don't want a via packed in this area. If anything, I would allow a ground via to be there, but so V negative coming up and around is not really a great idea. I drop down and go through. Not in a lot of places. I don't think I want my plus and minus to be this close. Well, this thing is pretty close to that. I don't like these vias to get too close to the chip. So from the bottom, 0.25. No, sir, I don't like it. See, this one just has to get over there, but that needs to dodge RL1 knob. Arduino Giga? What are you talking? What is that? Is that bigger than a nano? V negative needs like a big trace in this area, but a lot of the stuff is blocked. Let's bring the layer stack back because we just need to view these layers to see what possibilities exist. If I look at only the top layer, those need to connect to there. Not a lot of avenues here. My V plus is kind of irresponsibly laid out. If I go above, that still doesn't get me there. that the one that I just slapped an STM32H7 on a Mega outline? There's a lot of stuff like that out there now. There's all kinds of Arduinos. Nice. I hate that. So the volume knobs are what makes this whole thing kind of bonkers. They're flipping the negatives and the positives to where they don't really, they're on opposite sides. They need to keep twisting around each other. Why did I put a V on that one? Oh, because I already routed this. Huh. Well, that needs larger traces anyway. And luckily, there's not a ton of stuff going on here. So I could pretty easily get that out. I mean, oh, this is right here, so I can't do it that way. So I need to actually go through the leg down to the negative line down here. Plus from there, that, I guess I got to come up and around. And once again, I can just go from the bottom of the board by just coming over here. Probably have to cross over this, actually. No, that's going to get in the way. Oh my God, my brain. There's a lot of stuff to decide yet still. The decoupling capacitor should probably be more directly connected, but I have to come out and around everything on the top layer for this, which is crazy. I can't come from all the way over here. Oh my God, there's so many little decisions. This is madness. Why does that one go to there? Oh, that's probably the V plus pin on the actual IC. And this one's actually a really important one to avoid because this is the headphone amplifier and this makes a lot of heat. There's a lot of heat coming off of this thing. So with all that heat, I have to make sure that I get a nice big ground plane underneath it, which so far so good. I still have all my voltage to get in. So I need to find an area that I can drop down to the bottom of the circuit board and have V minus come in, V plus come in. Oh my God, my brain, my poor brain. Like I could bump L mix out, or I can just jump right down to here with V plus. So then V plus gets its own little lane right here. And I'm instantly cut off by the rest of the design. V plus is going here. So if I get to this side of the design here, I bump R mix over just a little bit, destroying my beautiful symmetry. My beautiful symmetry. Ah! That gives me room here for a via. I guess that could have fit in between the two. Couldn't have. It's not letting me. I'm just over here a little bit. We'll put her right there. Put her there, bud. And then I can come through with a 45-degree angle wiggly line. And then V plus is there. So what I guess I'm going to do is come around this thing like this, which is going to be hideous. Oh, that's going to have to get reworked. That does not look right. Gotta go to the real bendies, the 90 degrees. It gets me into there. Still haven't touched that decoupling cap, though. Okay, so then let's bring that across here and do it like that. Yeah, with the 90-degree bends, they don't stack up quite like the 45-degree ones. And if I have my one here, I wonder if I can fit the other one on the same side. It doesn't really look like I have space for it, though. With my R mix coming in there, negative there, and then those are stacked up to their maximum. There's just no way that I'm getting that in there. This is the side where everything can exit cordially. Oh boy. It's really supposed to be a decoupling capacitor, so it's supposed to be on the path. If I take it down this way, I can come down over to this plus. But then that left hand side is just blocking, blocking, blocking. I could take left way over to the left, and then V plus can come down and around. Yeah, that's got to be it. That's it. That's what we got to do. All right. There's a lot of ripping up in the design at this juncture, because things just kind of have to flow a certain way. So left is going to juke over to the other side. Come on, finish thinking. What's going on? Oh, I'm still in the unrouter. Around like this, and then that would cut off V minus in the same way. This is cursed. Unless this goes all the way around. It goes way over, practically to the edge of the board, up, like that. But I wanted V minus to come in, 3 V's for one trace, yeah. The keyboard PCB is at a point where I'm pretty much done with it. I don't know if much else is needed with that. So what I'm trying to do is order both of them at the same time. Oops, these need to be 0.25. I think I'll get this. There's just going to be a lot of weird stuff that I have to do in order to get it to be only 2 layers and not 3, 4. Could probably do this in 3 layers. Not that it's more expensive. Wait, am I still using the, yeah, 0.35 is just kind of like a nice number for the VIA. So left would have to go some circuitous route in order to get to the right place. V plus, I have switching places, but it doesn't really have to. It does in order to get around all of the other signals. And there's a lot going on the bottom layers. There's not much I can do there. I can't block this circle with a ground plane, but this thing has to go to ground. Save on shipping, or just so you get at the same time? Just because, I mean, I've got 2 designs going on simultaneously right now. And so if I finish this one, which we're getting closer to, I can order them both at the same time. And yeah, I guess it does save on shipping, but I fully expect there to be like errors in both of them. Personal errors, not errors from the board company. I expect there to be things that are wrong with the way that I've done things. I don't understand why Fusion has to put down this solder mask layer. I'm going to have to go in and manually delete the solder mask layers on these things. Because, like, it's just weird that they do that. In the settings, I have it off. I have it turned off. But it still puts it down. How in the world is this going to freaking work? Hold on a minute. This is left-hand audio signal coming in, or no, going out rather. And like V plus is here, left is here. I can't cross over because of the top and bottom layout. I've avoided V negative because V negative can't go into this area. There's going to be a big ground plane on top of all of this stuff. My other V plus is over here. So technically V plus could come in and attach over here, and it would avoid V minus, which is over here. So if I brought V plus in here, and minus comes down to here, we'll just temporarily do, I'll have to, well, let me just do it now. Let me do it now. This, and this, and this, and this, and this is going to be a 0.25, which I've already got configured in here. We've got to go to the bottom layer. Now I'm hoping that ground has more of an ability to slink in. And then where it does that, I can, oh boy, nope, it's starting to, I was going to branch it downwards on that, but it looks like it's going in flat. It's going to be the better way. Maybe move this up just a little bit. Was that an error? Was that? No, it's fine. Okay. That's a little clunky. Ugh. Nope. Okay, my nub is collapsing. You've done it. You've collapsed the nub. There we go. Okay. Still doesn't look quite right, but I think it'll be okay. And then our mix is right there. Oh, it's so cursed. I need room for voltage to come out of there. Our mix doesn't really get closer. Our mix gets rounder. Oh, no, it doesn't. There's no way. There's no way. Oh, I center clicked. That could have blown up the whole drawing. I guess it fits. It gets through. And this V minus is on the other side. Okay, so I got to go up and around. Hold on. Let's try again. What a nightmare. So that's not going to give me any leeway. What is that doing? All right, all right. Sometimes these just get angry at you. Oh, I see. Wrong size of trace. Hello? Oh, I hit done. I am far from done. If you guys noticed, what I did was that the top area was giving me trouble, so I switched over to the bottom just to get more ideas onto the paper and keep doing something instead of getting stuck. That's pretty much locked in. Oh, that's so ugly. Oh, that's so ugly. Not much I can do about it, though, other than like move it somewhere else. That's terrible. I really don't like that. I really don't like it. Not much I can do about it. I mean, I guess I can relegate it to doing a big diagonal. Point to this kind. I'm out of here. That. And we'll go in like that. That's a little better. Looks a little bit more natural. Like a natural PCB, like a PCB that you would find in nature. A natural PCB. Oh, bastard. No, just move over one. God damn it. Why are you like this? Ah, it'll be exactly in the middle. No deviation to either direction. If I could move it over a little bit, I can move it up, and that would give me a little bit more leeway. Which one goes where? Hold on a minute. Negative goes there. Positive goes on that side. So if I get this one out and around, I can hug the edge. Hug the edge and get it to go to the right spots. Let's hug the edge in a 2.5. Hug the edge. Give the edge just a big old hug. When I say, I'm going to give my puppy a big hug, Willow runs away. She just leaves. She says, well, I'm not doing that. You got to get curvy with them. We got to see where this one's going to come from. So, bendy into the centi. And then, I guess another bendy. I don't know. God, these are going to look stupid. They're going to look terrible. The bendy traces don't look great when they have to do 90 degrees because you got to put two of them together. This one's better served by that. Oh, it looks terrible. It looks so bad. Can I get just like a normal bend? No, I don't think so. Looks like a weird face. There just isn't a cooler way. No, stop it. Stop it. Nasty. It's just this just looks nasty. 3 vias for each trace. No need to worry about overheating. I don't understand why the via placer does not allow me to turn off solder mask. I think it's an error in the program. Which is maybe why I need to create my own like via. Put those as close to this as possible because I can't put them over here because there's no solder there. Make it look as boob-like as possible. There you go. Little nipple in the middle. That was clunky. Very, very clunky. I mean, there's no reality under which this is not clunky. So let's get our V negative in there. And what I want to do is avoid this, we got a nice big area here. We've got this huge big area where our ground's going to come in, but also dissipate heat. So that's going to be really, really good. What is that doing there? Hey, Bud? Bud, what's going on here? What are you? You have you're a ground pin. Okay. Weird. Wonder how that ended up there. We're not doing that part of it yet. All right, so let's just go 0.25 V negative, pop one of these in here. Then we can go up and over with my accent. We can do our diagonals here. And really kind of, I don't know. Should I hug it a little bit more? I guess so. Those ground planes are really going to want to like populate this right here. So maybe I should just shoot for the middle. It does kind of cut off things over here though. It would be nice if all these layers had a nice big ground plane in there. And I think the best way to achieve that would be to be using 4 layers. Because 4 layers is only like $20 or $30 more to get all of your boards made. It's not that big of an expense for the benefit that you'd see in the ease of layout and this and that and the other thing. You know, honestly, the power play here would have been to do 4-layer PCBs through and through, and that would get me what I probably am desiring in terms of the building of this board. But I refuse to go with any more than 2 layers because of the challenge. That's connected, although V negative is now parallel to N39, which is an amplifier trace. To be fair, I could have used a different amplifier in this as well, but I had to use, for my own purposes, I had to use a bespoke headphone amplifier chip. I wanted it to be cool. Why is there no solder mask around these pins? Is that just inherent to the... or am I looking at a bad... None of my chips have solder mask. Oh, maybe it's on like pin masking. It's on a slightly different layer. Oh no, we're not viewing the bottom solder mask, that's why. Is there no bottom solder mask for the vias? No, the vias get both. It's a hatched line. Yeah, see, there's the solder mask for the bottom layer. Oh my god, there's just no room for a via here. This one might be the hottest chip of all of them. Say what you will, it's an aesthetic. I'm trying. Having stuff like this is really hard on my poor heart. Like weirdly hugging that thing. Yeah, there's no getting around that, is there? Way it is the way it's got to be. It's just got to be the way it is. Yes, sir. V negative, this needs to be larger. So what Fusion has is it has a change tool. Hold on, one sec. Oh man, coughing so much this season. So Rework, there's a tool, no, not Rework, Modify has a tool called Change. Change changes any of the parameters of the item. So I can go to size and I can select 2.5. I guess I got to put it in myself. Is that a width? A width already has them. Okay, width I can change it to 0.25, and then anything that I click on will go to that size. I can bust open all of my positive and negative lines that I missed and make them the proper width to get the current. Oh, that's pleasant. How's that going to work? Oh, I guess doing change tool again. Background's going to be tough to get in there. So, C, big menu, width, 2.5, click. That's left mix, right up in the patootie of my V plus over here. You think the technology in your insulin pump could be adapted for other hormonal imbalances like PTSD symptoms, anxiety disorders, Parkinson's, and depression? That's a lot of things people are already doing. There was a user in my chat in the past, many years ago. I hope they're still doing all right. I haven't heard any updates from them, but they were living with chronic pain, and they had a pain medication in an insulin pump, and so it would drip feed the pain medication to them, which is a perfectly cromulent application of the insulin pump. There are plenty of other applications like that for pumps. In fact, they put glucose in an insulin pump, paradoxically, in order to have an auto pancreas system, so that you had a mechanism for raising the blood sugar and lowering the blood sugar, not in the same package. It was in two different pumps on one person, one student. Oh my God, how am I going to make this happen for the rest of this board? There's a lot of crazy spots that I'm going to need to get these vias into. What in the world? V plus over to there, and so I've got all these pads with V plus on it. And nowhere for them to go because I've already routed all the other traces. And I've got V pluses here that need to get to the next stage as well, which is over here where the V plus and the V minus are on the opposite sides of where they are elsewhere on the board. Yeah. And then that maybe I could sneak in a little bit, but that's not going to give me any room. If you leveled off with the prosthetic hormones, you could also wean off to a natural homeostasis. That's not necessarily true of someone's condition. Chronic pain is a hell of a thing. It's a hell of a thing. Let's leave it at that. Should that one also be point? I guess so. I guess that one should be big too. So I need to go change that down here. B plus, and then these need to be, I don't know if I can expand these two. Change again. Width, point, no. Screwed it up, hit escape, hit C. Width, 0.25. Looks like I can get away with it. This thing is, I don't know if it's current hungry or if these traces would be fine, but this chip gets hot, so it does a lot of work. I hate that I had to come into the side of this. I wish I could have come straight on. But I need this capacitor there. There is just no room for anything else on this board. This board is doing everything it possibly can. My chemo pump was cool as hell. It was a ball that shrunk to pump those nasty drugs into my line. Oh, so they had just like a little beer ball that they hooked up to you, and it just kind of like a water balloon. Like a water balloon, and then something bad happens. Another via on this side of the L-mix line would get me to fucking nowhere. It all cuts off. Really, what I need is V plus to be here. but there's too much to cross over. Unless I bump this down somehow and come back up this way, and then I could get here on the, not on the blue layer, no, but then volume knob gets in the way. Volume knob could be bumped down here, and then I would have a blue path through, or sorry, a red path through to get V plus over there. I don't know if a 0.25 is going to fit in between all these. This is crazy. This is where I'm going to run into kind of all of my problems, is routing these traces. I have no idea how it worked. V plus immediately changing layers. It goes under the two signals there. Plenty of room here to route, except that L mix jumps out right there. And it has to, because the blue stuff gets in the way. Down here, blue stuff in the way, blue stuff in the way, blue stuff in the way, red stuff in the way if I come up any sooner. This is the soonest that I can jump out, and it strangles this right here. Because now this is surrounded by red and blue. Unless I come up and I gracefully come up the very edge of the board, which is a bad idea because stuff's going to happen on the edge of the board. If I branch this out, I'm immediately met with V negative, which could move over. That could be pushed over, but it's actually in the chamber that's holding this minus pad for the component right there. That pretty much cinches V negative all the way up to here, and then it becomes an air wire again, which is good, but also limiting. This is getting tough. This is a tough one. I will crack this egg. This is something that I know I can do. There's just a lot of this and then this, and then this does this, and then this affects this and that. I can see the way they want to auto route it, but I don't think that's going to be very pleasant to look at. The auto router does a lot of crazy stuff. C for change. Wait for the pop-up, which takes forever. 0.25, select it again. Bonk. Bonk. All the power delivery traces I want to be 0.25. It's not much. It should be probably even bigger than that, because you want to give it big traces to bring in power so that, you know, it's clean and effective power. Clean coal. V plus. Man, there's no way to get V plus over to the other side. This is just problem after problem after problem. Going horizontally and vertically on the two layers is sort of partially what does this, where you end up getting locked into a little pocket where you can't get any signals out of it. And it's just a matter of scratching my head at it enough and then making some kind of a compromise somewhere. Like, yeah, I could avoid all this stuff if I do this up and around a little higher up. What's that going to get me? It's not going to get me anything. If I lift this up to here, oh no, I have to avoid that pin, yeah. I certainly have had easier to lay out boards, that's for sure. Make that a little bit more compact, and then I have room for V minus to do what? To jump to a via. It's always my solution. Go further up. We'd solved all of these problems, and now I've got all these new problems. This is really the goal of where we're going to, which is where the power supply connects to everybody. Well, I'm at an impasse. I think my brain has stopped working. A little bit of circuit board design goes a long way. I hope I've ushered many of you into the world of questions, the world of problems that you have when you do something like this. You know, what's going to go here? How do I make this go here? I want a bigger ground plane over here. I want to not violate all of my 2D and 3D documents are out of sync. Oh my God, let's just run the 3D board just quickly, just to see what that looks like. Don't ask me to check my blood sugar, please. Makes me want to use 4 layers instead of 2. 4 layers is only a little bit more expensive. It's only a couple bucks more. Come on, buddy. So although we can technically see the traces, we're not going to be able to see the traces that we put down. Using 4 layers means that you can use the internal layers specifically for power. Makes your design a lot cleaner. And while I can go to 4 layers, I am debating about whether or not I want to. I might do. I just don't understand why that silk screen didn't undo the solder mask layer. I said no solder mask on the vias, and it didn't listen to me. It put it in there anyway. It might be a bug that currently is in the system, but there really shouldn't have been. I wonder if I can go into that layer and delete it. I think he yelled at me last time, though. Wanted me to delete the entire thing. If I only view the layer, maybe I'll be able to get rid of that. But yeah, so the design continues. The traces go down. It really doesn't look all that dense from this side. The other side is where, of course, all those traces sort of interconnect with one another. So you get a lot more stuff on that side. It's getting there. This thing has been a beast of a design. It's a beast of a design. It's going to be a beast of a mixer. It's so complicated. I keep saying it's so complicated because it has to have 4 independent control of channels with controls for each thing. I could technically take this in to an I2S audio, like D to A, right? Take 2 channels, 2 D to A's, take 2 channels in, put an RP2040 down on the board, and then have the knobs all be 0 to 3.3 volts. It would be a whole 3.3 volt circuit. Then it would go to I2S output, a singular I2S output, which does 2 channels. And so we could put all that together. I could use Paul Stoffrigan's wonderful software that helps you organize the audio stuff in and out. And then I could wire it up just using numbers inside of code. And it would be a perfectly functional mixer. I don't know if my friends would be able to tell if the audio that they're putting in is not analog from end to end. We insisted on doing analog end to end. That looks awkward right there. That's a little awkward. I could probably come up off of the edge here. But yeah, we insisted on doing analog from end to end, so it required a lot of chips and a lot of weird things to occur inside of the design. But we're getting there. We are getting there. We are getting there, but I'm burnt out. I can't think about this anymore. There's too many things going on. I will, of course, work on this in the background. The next steps, by the way, once we're done getting all of these power traces laid out, you then have to do a polygonal pour. It's a fill. You draw a polygon around the board, and that pours in your ground plane, and it just automatically does all the connections to all the little like heat-based thermal pads. That's what we're talking about. Thermal pads where it's not just like an opening and stuff. It's yeah. Analog isn't a higher phi, but it has texture. Also less delay. The signal coming in will be very similar to the signal going out. Whereas in a digital system, it has to encode it, operate on it digitally, and then output it. So, I mean, while I could do that in like an FPGA, I2S to a microcontroller working its ass off, it could then do all that mixing on its own, but oh well. GTX, mine's an FTW. There are analog FPV drones? I guess that makes sense. Although I thought most of FPV was FPV even first person, so I guess analog would be good because then you don't have a delay in broadcast in the video. but then it's also really crunchy video on that 5.8 gigahertz. All right, it's coming along. This thing is tiny, but it packs a punch. It's going to be generating a lot of heat too. And I guess I would like to have soft edges on these corners. We'll work on that later. We will come back to that, but I think tomorrow we should Tasmotize some light bulbs, because then I can get them working with Node Red, and I can do some of those other things that I've been meaning to get to. And then that leads us into Node Red being a front end for Twitch. Currently, it can communicate with my OBS. I needed to do the Twitch API, because that'll be the main front end of the whole shop. That'll hook us up to the Twitch API. It can get my interactive stuff back. You guys will get your fart box back finally. You guys have been saving up so many farts. I think you got to go see the doctor or something. You guys are going to get injured. It's not good. It's not good. Nobody's going to benefit. There's going to be a fartalanche, the likes of which the world has never seen on this channel. So I'm going to quickly take a peek at Twitch, but I don't think we're going to raid anybody. We haven't raided a lot of people lately, and I do need to step up with that, but everybody's schedule seems to be just a little bit off of mine. I'm one of these rare East Coast of the US streamers. Boom is on. Rabaz is doing OpenShour still. Those guys have got to get so sick of OpenShour. He's been doing that for like a month. Father Midas the trace. All the traces move up. Oh, God. And then the whole board explodes. Yeah, that is what happens. Analog OTA TV switched digitally. That was perfect for nothing. Yeah. The FPV stuff that I have is analog. It's older stuff. So I guess it's still a digital screen, but it is receiving a signal that's analog, so it'll be pretty quick. We'll destroy the ozone with farts. The neighborhood's going to be uninhabitable. It'll be the next East Coast major disasters. Obother's shop is going to emit methane, the likes of which this world has never seen and will never see again. Here's the end card. Here's the end card with all my information on it, including my beautiful, wonderful social media website. There we go. That's muted, right? Yeah. Why did I recognize end? Oh yeah, because that's an admin window. Yeah. Okay. I don't know why. Oh no, because I was looking at who was streaming. That's why that was open. That's the thing. I'm so frazzled right now from doing that much PCB design that I forgot that I opened up a new window to look at who was streaming and talk to you guys for a minute. Yeah, Philly air quality indexes will never be the same. Anyway, yeah, we're gonna, we're taking steps towards getting the interactivity stuff working, which is steps towards burn the subs. So there's people that come in, there's assholes that come in and are like, when's burn the subs gonna get working again? They don't know that I do these little incremental pieces of project. Everything that we've been doing has been slowly pushing stuff forward to fruition, just to keep me from burning out. Yeah, you guys have a good evening. I will be on Discord. The Discord link was over there, and maybe I'll come up with some kind of a skeet in the near future, just to keep my social media presence somewhat going. And I will catch you guys later. I'll be on tomorrow about the same time. So if you didn't catch me today, be a little bit earlier. I'll be right here.